Congratulations on mastering the intricate dance of the Spring framework. You've built a solid foundation, but guess what? There's a whole universe waiting to be explored, the enigmatic realm of Spring Data JPA. Ever wondered how the pros handle data persistence in style? We're about to reveal the secrets that will transform you from a Spring enthusiast to a data wizard. Buckle up for a thrilling ride through repositories, relationships, and the art of querying with finesse. You've tasted the sweetness of Spring Boot success. Now let's add the spice of Spring Data JPA to your coding journey. Get ready to play with embedded entities, master the nuance of ID generation, and harness the power of named queries and specifications. Before we dive into the nitty-gritty, don't forget to subscribe to my YouTube channel and join our vibrant community. Elevate your coding skills with fresh weekly content delivered straight to your virtual doorstep. All the links are conveniently waiting for you in the video description. Don't miss out the coding adventure. Your seat is already reserved. Now that you're logged, loaded, and subscribed, let's get back to business. Spring Boot was just the beginning. Spring Data JPA is the next frontier. Ready to unravel the mysteries? Grab your coding gear, hit play, and let's embark on the epic coding journey together. Let's get started. First of all, we will start by setting up our database management system. And for the purpose of this course, I will be using Docker. And I will show you how you can install PostgreSQL or MySQL database. So you have multiple choice. Also, if you have them already installed on your machine, you can skip this part. So this part is only about installing and setting up the database management system on your machine. So first of all, make sure that you have Docker desktop running, installed and running. And here, like when you open the Docker dashboard, you will see this green part like here, or this green icon. So this means that the engine is running. So if it's an orange color, means that the engine is whether it's starting or it's not started. So you need to make sure that this is green. And this is all you need to do. Okay, now let's move and install the Docker image for PostgreSQL. The command that we need to run is the following. So here we need to use the command docker run, and then -d to say we want it to be running in detached mode, so we don't want to wait for it. And now we want our Docker image to be persistent, or to have a persistent volume within our system, because as you know, every time you start a Docker image, it will start like from scratch, and it will consider that nothing is persistent. So if we want to have a persistent Docker volume, you need to add this option -v, it's for volume. And now for the volume, first of all, you need to specify the path where you want to store the data of PostgreSQL. And for example, in my case, so it will be in here. So I just called it this way. It's my personal project data/pg for Postgre and data for data. And then just colon here and /var. So here we are trying to map the volume from our local machine to the volume that PostgreSQL will be using. Okay, so it will be /var /lib /PostgreSQL /data. So this is the path that PostgreSQL uses to store the data. Okay, so now we mapped already the volume. Now we can also pass some environment variable. And these environment variables, we need them for the username and the password. Okay, so to pass an environment variable, it's like following. It's -e, and then we have Postgre _username. These are predefined environment variable that PostgreSQL will look for. And here I will call it just Postgres or Postgre. And then minus E, I want to pass a second environment variable, and this one, it will be a Postgres password. Okay, it's a Postgres underscore password, and here I will call it Alibu coding for the password. Okay, and now we need to map the port. So this means on which port we want to run our application. So let's keep it the default one, which is 5432 colon 5432. Okay, so we will be using, or we will be connecting to our Postgres SQL on the port 5432. Okay, so now all we need to do now is to precise or to specify the image name, which is in our case, like we said, we want to use Postgres, so it's gonna be Postgres. Now let's hit the enter button and see how it will do. So here it says that unable to find the image Postgres latest locally, so it will be pulling it from library / PostgreSQL, so means it will download the image, and now we see that we have this status downloaded image or new image from Postgres latest, and here we have the hash of the image. Also, you can go to Docker dashboard, and you will see here that we have this image, and if you go to containers, you will see the container which is running. Okay, so and here you can see that we have this container which is up and running. Okay, so to install MySQL using Docker, we will follow the same steps. So it will be docker run minus d as d for detached, and now we want our database, or we want our image to be persistent or to have a persistent volume, so we can also precise the minus v, which stands for volume, and I want my volume or my persistent volume to be in this path. So it's up to you to choose where you want to have your persistent volumes, and then colon /var /lib /mysql /data. So this is what MySQL uses for data, and now we need also to precise some environment variables, and in this case, or for MySQL, if we do not precise, for example, the username, it will take the root as default username. So I will keep it just root. So I will only precise MySQL or this environment variable, which is the root password. Okay, so it's MySQL underscore root underscore password equals, and I will keep it empty, or you can leave it empty. So I want to have an empty password for MySQL. Next, we need to precise the port, so it will be 3306 mapped also to 3306. Okay, and then of course the image, it's MySQL or MySQL. Okay, now let's hit the enter button, and it will download or pull the image. So now it's extracting, and in just a few seconds it will be done, and we will be able to see the hash. So this is the digest or the SHA of the pulled image, and this is the ID of the image, and also to make sure that everything was fine and okay, you can go to image, refresh in here, and you can see what we have, the MySQL running, and it's already in use. So if you click on this one, you will see it here that it's up and running. Okay, to create a new Spring Boot project, the recommended way, and also the way that I really recommend, is to go to the Spring Initializer website, which is at this address, start.spring.io, and here you have a graphic user interface or a website that you can use to create a Spring Boot project. Okay, so let's go ahead step by step and create our Spring Boot project. So first of all, you can choose which project first of all, you can use which dependency manager you want to use. So if you want Maven or Gradle project, or here you have also the option for Gradle Kotlin for people that want to use Kotlin instead of Java. And here you can also specify the language, Java, Kotlin, or Groovy. So for us, we will go for the standards, which is Maven and Java. For this tutorial or for this course, because Spring 3 is already out, so we will be, from now on, we will be using the Spring 3 version. Okay, now let's specify or precise the project metadata. So here the group ID, it will be, let's call it com.alibu coding. And the artifact, let's call it, because this is a Spring Data JPA course, I will call it just JPA. So this is Spring, and the description, you can leave it or you can put whatever you want. So let's just leave it, and this will be our base package or the package name. So we want a jar packaging, and of course we will use the Java 17 for our project. Okay. Now let's add some dependencies that we will need within our project. So first of all, we need Spring Data JPA. And for the people that would be using PostgreSQL, just choose PostgreSQL driver. For the people that they want to use the MySQL, just go ahead with the MySQL driver. Okay. Next, we need Lombok. So Lombok, it's, as you know, it's an annotation which helps us to reduce the boilerplate code. And I will be explaining all the annotations that we will use within our project. And also I will add Spring Web, just in case we need, for example, if you want to need to expose some controllers or something like that, you can use the Spring Web. Okay, so now once everything is set up, you have all the dependencies, you have all the metadata, and you configured everything. So we can first go and explore the project before downloading it. And as you can see here, we have all the information. So the parent is a Spring Boot starter parent with the version 3. And here we have the group ID and the artifact that we precised. By default, the version is 001 snapshot. And the name is JPA. Okay. Also, we have the properties, Java 17, and so on and so forth. And here we have all the dependencies that we want to use. And in the end, we have this build plugin, which is the default one from the Spring Boot framework. And yeah. Okay, so now let's just go ahead and click on download and open our project using IntelliJ or your preferred IDE. To connect to our database, there are so many ways to do it. My preferred way, I want to have everything in one place, so I always go with the database option within IntelliJ. So by the way, this is the new interface, so you can download the latest version and enable the beta UI, and you will have the same view as me. Okay, so let's go back to our database. So in order to connect, you have this menu right here which called database, but if you don't see it, you can go to view, and then you have tool window, and then you can see here database. So if you click on database, it will open up this window right here. All right, so now let's create or connect to our data source. Let's start with PostgreSQL. So just click on this plus icon. Let me make it a bit bigger like that. So when you click on data source, you have here a list of databases or databases management system. So here, for example, you can also filter. Type Postgre to filter for PostgreSQL, and then click on it. Okay, so this window will show. And here we will have a default name, which is Postgres localhost, and here you can add some comments. You can also see the connection type, which is default, and the driver, which is PostgreSQL driver. So this is not the driver that we included to our pom.xml, but it's the driver needed by IntelliJ or the the database view system that you want to use to be able to connect to the database. So here you have PostgreSQL, but for the first time it might require you to download the driver. So just go ahead and click on download the driver. It will be in the bottom here next to test connection. And now let's go and configure our database. So as you remember from the previous part, when we set up our PostgreSQL, we chose the default port, which is 5432, and then we chose username and password. So for the username, we said it's Postgre, and for the password, we chose Alibu coding as a password. Okay, now just go and click on test connection once you provide all the correct information. So if you used a different port in here, just precise it. Same for the local host and so on and so forth. So when you click on test connection, so you need to expect this succeeded, otherwise you have something wrong, whether the password or something like that. So let's do apply, okay, and let's check what we have in here. So here we see that we have our PostgreSQL, and here you have one of three schemas or one of three databases. So these also are my old databases, or the one that I'm using for other projects. So now the first thing, let's go ahead and create our database. Okay, so right click and then new, and then you choose database to create the new schema. Let's call it data JPA. Okay, data underscore JPA, because this is the purpose of this course. Now just click OK. It's updating or creating the database, and then all you need to do, click on this 0 of 3 icon, and then just select the public. So you will have the public schema by default. Okay, and then every in the future, or when we create a new table, it will appear under this public right here. Okay, so now we have our PostgreSQL set up and running within our application. So let's move to the next. For the students or for the users that prefer using MySQL instead of PostgreSQL, so in the same way, you have this icon right here that represents the database. When you click on it, it will open a window like that. But if you can't see it, just go to View menu and then Tool Windows, and then you will see database. Just click on it and you will have this view available for you. All right, now let's click on this plus icon to add a new data source. And here, like I have it already in the recent used, but also you can filter by typing MySQL and it will pop up. Okay, so then you need to precise the same information that you gave when creating the Docker image. So the local host or the host, it's always localhost, and the port, if you followed my exact same configuration, it should be also 3306. And for the user, it's root, and the password we didn't precise, so just go ahead and click on test connection. Okay, so when you just provide the username and password, if you have a username and password, but if you didn't provide a password, so just leave it empty. And when you click, you will see this succeeded, means that you are able to connect to your database. Also, one hint, be careful and make sure that you have your container running. So otherwise you will not be able to connect to the database. Okay, so I will click on OK. And now we see that we have our local host for MySQL. Let's configure our project to be able to connect to our database. And we will start with connecting to PostgreSQL. But this is important because it's the same configuration and only few changes would be different from MySQL or PostgreSQL. So the first thing, just go to resources in here and here we have our application properties files. So I like, or I prefer using YAML representation. So it's the same thing. The only, or the main difference is just the way we write the properties. So I will use YAML representation. If you want to use properties, it's also okay. So just go ahead, first of all, rename the application properties to application.yaml. Okay. Next, now we will start providing information or providing properties to our application or to Spring container to be able to connect to the database. So first of all, the first property will be Spring dot data source, and then we need to provide the URL. Okay, so to be able to connect to a database, we need to provide few information, because we have the Spring Data JPA starter within our dependencies. So we need to provide the minimum required of information. Okay, so for that case, we need the URL. I will just come back to it later. We need username. So in our no, not Hikari, just username. So for our case, for PostgreSQL, we said that it's Postgres, and for the password, why this Hikari? And for the password, we said we want to use Alibu coding as password, and then we need to provide also the driver class name. And the driver class name, you see here that we have already three suggestions. So the first one, or the first one is for MySQL or MySQL. The second one is for PostgreSQL, because IntelliJ is smart enough to detect that we have these dependencies in our pom.xml, so it will suggest it. Okay, so now what we need to do. The first one, we want to configure it for PostgreSQL, so just choose the second option or the first. I don't know the order that it will pop up for you. And yeah, that's it. Now let's add some other configuration. Okay, here I will add JPA, and here I want to tell or to give some extra properties to Spring configuration or to the Spring Data JPA on how to connect or how to manage or how to work with my database. Okay, and the first property is part of Hibernate, and it's called DDL Auto. This means what do we want to do when the application starts. Okay, so we have many options. The first one is create drop. This means that we'll create and destroy the schema at the end of the execution or the lifecycle of our application. So when the application starts, we will create the schema and the tables, and when we stop the application, we will drop or we will remove everything. So be careful when choosing this one. The second option is create. So when the application starts, it will destroy all the previous data and recreate the schema from scratch. So this is also, you need to be careful about it. We have also the none options, mean that we want to disable the DDL handling. That this means that we don't want to do anything when the application starts. Last but not least, the update option means that we want to update the schema if necessary. So this means what? This means that Hibernate will compare the Java representation or the entities. It will compare them to the table or the database schema that we have, and it will try to make it even. But here you need to put in mind something which is really important. The update option, it will not remove attributes. So for example, if you have an entity and you create and you want to remove an attribute and replace it, or like create other ones, it will create the new attributes, but it will not remove the existing ones. Okay, so also you need to know that, and you need to be careful about this. The last option is validate. This means, what means validate? This, it will not do any changes but it will just validate the schema comparing to the Java representation or the entity representation. So we have, for example, user entity and we have a user table. So the validate will check if we have the same table name, same attributes, same attribute names, same types, and so on and so forth. So it will just validate that what we have as code is the same as what we have within our database. So for our configuration, let's say create drop, because this is a learning course, so we don't need to persist data forever. So create drop should be fine for us. So let's go with create drop, and now we can also precise the database. This will help Spring, or will help also Hibernate, to know which database we are dealing with. So it will just enforce the way that we will update and manage our database. Okay, so here we have also the option show SQL. Let's set it to true because we want to see SQL queries. Okay, so now this is the main configuration, or this is the configuration that we need to do. Now we will need to go back to this URL, and the difference between, for example, configuring MySQL and configuring PostgreSQL is just providing the URL, the correct driver class name, and here this option right here, you can also change it to say it's MySQL. Okay, so now going back to this URL, so it's JDBC, it's always like that, jdbc.postgresql :// and then you need to provide the local host, or well, whether it can be local host if it's locally, or it can be an IP address, or it can be a URL, and so on and so forth. So now we need to provide the port, which is 5432, and then the database name. As a reminder, the database name we created here, we called it data_JPA. So here let's just provide it. So now our application will be able to connect to this one. So how to test it? What we can do, we can just go ahead and start the application and see if we are able to connect to the database. Now I will enable annotation processing because we have Lombok within our application. And as you can see here, so the application already started in 2.9 seconds and without any issues. So everything is up, and because we don't have any tables, so we don't have any further information. But if something is wrong, we would see that we have exceptions in here, and I will just show it to you. So for example, if I provide the wrong port name, number, sorry, not name. So if we provide the wrong port number and we try to connect to the database, we will see that we have a connection issue, and it will say that unable to connect to this localhost 5431. So connection refused, and so on and so forth. So this just to ensure you that when you have the correct configuration, you will have no issues when connecting or when starting the application. Okay, so now our application is ready to use. Let's move on. We will add now the properties to connect to my SQL database. And to do that, I highly recommend that if you skipped the first part to connect or to configure PostgreSQL, I would really recommend that you go back, because we explained all these parts. So it's really, really important that you go back and check that. Now I would show you how to configure or how to connect to MySQL. The first thing, let's go ahead and applicate this application.yaml. Just copy and paste, just Command C, Command V. Also, just as a reminder, every time I use a shortcut, you can see the green pop-up down here. So yeah, you can always follow what I'm doing. So now I will just say MySQL, or just the new file, I will call it application-MySQL. So this, we can use it as a profile, as a Spring profile. And I will show you how you can run the application, whether for MySQL or MySQL or PostgreSQL. So how you can configure IntelliJ to run with a specific profile. We will see it just in the end of this video. Okay, just go ahead and click OK, and let's start do the changes that we need. Okay, let's put this in full screen, or even I guess it's also like that is readable. So the first thing we need to, of course, change the username and password. So for MySQL, it's root, and we will see if it works or not. Let's go ahead and change the driver. And now we want to use the MySQL driver. Okay. And for the database, we want also to use MySQL or MySQL. Now we need to change, or we need to update this URL and connect to the database. So the good thing is within MySQL, you can ask him to create a database automatically if it doesn't exist, or if the database does not exist. So MySQL will create it. So MySQL will create it automatically for you. The URL is here. Instead of let's remove it. Let's write it from scratch. So it's JDBC, and here MySQL, and then ://. Now we need to provide the URL of the database. So it's localhost :3306. This is the port that we want to use. And then we want to use also the same database, or the same database name here. So just for to be convenient, so I will call it also data JPA. Okay, and also you remember that we did not create manually the database, because as I mentioned, MySQL has the option, or has the capability to automatically create a database if not exists. So to do so, just add interrogation mark and add this parameter, which called create database if not exists, equals true. And that's it. So like that, it automatically MySQL will try to create, or will create a database called data JPA if not exists. Okay. Now to run the application using this configuration, first, before clicking on this play button right here to run the application, just click on JPA application, and you will see edit configurations here. And here you see that we have active profiles. So Spring, now if I precise it as MySQL, Spring, what will do when starting the application, he will try to find an application properties file, or properties file having the suffix MySQL as precised in the configuration in here. Okay. So here we said that the active profile we want it to be MySQL. By the way, we can provide many active profiles. As you can see here, it's profiles, not profiles. So we can provide many, but in our case, we want to connect to application-mysql.yaml file. So Spring will automatically try to scan and read this file if it exists. Okay. I will click the run. And let's see if the application is going to start correctly or not. Yes. All right. So we see here something that I didn't know. So here we see that loading class, this one, but it's deprecated, and the new driver is the one that we saw in the options. Okay. So we will just update it later on. Now I want to go and check the schema. Let's refresh this one. And here we see that we have now 5 schemas, and we see our database data JPA. So we don't have nothing yet, but this one, once we create the tables and the entities, we will have all the tables in here. So let's do the final update, and let's replace this with a new driver using this package, and that's it. For this course, we will implement the following database class diagram. So this database class diagram is about e-learning platform and what it's about exactly. So it talks about how we can, for example, if you go to Alibu Coding and check the courses that I have there, so what you see, this is what we have behind the scenes. So we have courses, sections, lectures, and for each lecture we have a resource, and the course has an author, and so on and so forth. So this is what we will see. But first, let me explain to you in depth this class diagram. So we have a course. So for example, this one that you are following right now, which is mastering Spring Data JPA step by step. So we have a course, and this course has an author, okay? But a course can be done by many authors, right? And the same author can create many courses. So for example, I can create so many courses, and one course can be created within a collaboration of multiple or many authors, okay? So that's why here we have this many-to-many relationship. But here, create an author, having an author within our database doesn't mean that this author should already have a course within the database. But if we have a course, we should have at least one author assigned to that, because when we want to create a course, we need to assign it to at least one author, okay? So that's why you see you see this symbol right here, and you see this one right here, means that the author is optional to have courses, but a course is mandatory to be assigned or to be done or to be created by an author. Then you know that a course has one or many sections, okay? So here, when we create a course, we need to create at least one section, but we can have multiple sections for one course. And here, just put few attributes, just simple ones, like title, description, name, and order for the section, and so on and so forth. Okay, so as I mentioned, a course has one or many sections, but one section, if we take one section, it belongs to one course, and within the course we can have many sections that belong to that course, okay? All right, next one, when we talk about sections, we have many lectures, okay? We have so many, one or many lectures. And one lecture, if we take one lecture, it belongs to one section. So this means that we cannot have one lecture that belongs or can figure out in different sections, okay? So if we take the section A that has lecture 1 and lecture 2, so this lecture 1, it belongs only to this section A. We cannot find it as part of section C or section D, for example, okay? Now, after that, a lecture has a type or has a resource, okay? So a lecture has one resource, and this resource belongs only to this one lecture. So that's why here we have this one-to-one relationship between the lecture and the resource. And for the resource, we have, of course, the ID, name, size, and URL. And the resource can be of different types. So I just created a simple types here, for example, video, file, or text. So this represents a resource, okay? So here what we have inheritance between this resource class or resource table and this video, file, and text objects, okay? So for the video, we have the length, for example, how many minutes this video. For the file, we have the type, for example, whether if it's PDF, MP3, and so on and so forth. And we have for the text, we have the content, and all these three types or three types of resources, they are already a resource and they can be assigned to a lecture. Okay, so this is our class diagram, and this is what we will implement during this course. So we will go through all this one by one, and each time or every time we need to explain something, we will go ahead and create and see how we do that. And also we will see how to create advanced search queries, how to work with transactions, and so on and so forth. So you already saw the plan of the course, and this is what we will be implementing. Before we go further, let's first understand and explain the difference between Hibernate and Spring Data JPA. So first, Spring Data JPA is just an abstraction layer on top of JPA to reduce the amount of boilerplate code required to implement data access objects, or what we call DAO or DAO. But JPA, what is JPA? JPA is just a specification that facilitates object relation mapping to manage relational data in Java applications. This means what? We can consider JPA as a Java interface where we have or where we define the methods that we want them to be implemented by any class that wants to use or implement this interface. And why is that? Because we have so many implementations, like for example, we have Hibernate, we have Eclipse Link, we have iBatis, and so on and so forth, that all of them, they should implement the JPA specification. And the reason behind that is we want to make coders or developers' life much easier. So for example, if you want to move from Hibernate to Eclipse Link, all you need to do is to do a minimum configuration or minimal changes, like changing the dependency or maybe some basic configurations. But for example, if you have a save method, it's exact the same method for Hibernate and Eclipse Link, for example. This is what JPA exactly. As I mentioned, JPA is just the specification. Okay, now if we go to the Hibernate level, so Hibernate is a JPA implementation, and also Hibernate generates SQL query and executes using JDBC. So Hibernate is the ORM, the object relational mapping, that will use JDBC to handle all the database side, means like saving, reading, deleting, and so on and so forth. Okay, so this is the main difference between Hibernate and Spring Data JPA. So let me also re-explain this part. So instead of doing all the implementation and defining the session management, and so the transaction management also, and so on and so forth, that Hibernate provides, so Spring Data JPA will do all this job for us, because as you know, when using the Spring Data JPA starter, it will auto configure almost everything for us. So yeah, this is the power of the Spring Data JPA. Let's see first how we can transform a table or a database table to a Java class and to be able to manipulate it within our application. So let me explain this diagram right here. So we have this author.java that we will take as a first example, and we want to persist this object into our database, and we want it to be stored directly into the author table. Okay, so we have our author.java that contains a set of attributes, ID, first name, last name, email, and age. And then what we will see next is which annotations that we need to use in order to make Spring Data JPA understand that this is a table or this is an entity and needs to be persisted, and so forth. Okay, so let's go to our IntelliJ. Now let's create within our base package com.alibucoding.jpa. Let's create a new class, or let's create a new class, a Java class in here. But if you want, for example, if you don't have the right package ready to use, just when you want to create the class, you can precise the package name. For example, if you want to call them models, or if you want to call them entity or entities, it's up to you. So you just give them the package name, for example, let's say models in here, and then you can precise the class name. So for us, we want to create the author Java class, and we want it to be within the models package. So when you hit enter, so this is what we see in here, and we have author created under the package models. Okay, so now, as we mentioned before, let's just create our attributes. So here, just a reminder, we want to create ID of type integer, first name, last name, and email of type string, and we have an age of type int. Here I have a private integer ID, and I have a string first name, and I have also a last name, private string email, and finally I have a private int age. So this is my Java class. Now what we need to do, or like normally or usually what needs to be done when you create a Java class, or when you create, especially when we talk about entities and so on and so forth. So always think about generating getters and setters. So make all the fields private and generate getters and setters. So to do so, there is a shortcut in here, like as you can see, like you can generate it using this shortcut. And here we have getter and setter. Here you can select all the fields that you want to generate getters and setters for, and then just click OK. And you will see that we have all these methods ready to use. But if you remember, I will just roll back this. So if you remember, we already added Lombok to our project, or to our pom.xml. So let's use Lombok for that. Okay. So the Lombok annotations, we have many annotations, many useful annotations. We have the getter annotation, and as you can see, it's always from the package Lombok. So this will generate getters for this class, and also we want setters. So this will generate, this annotation will help us generate setters or setter methods for all the attributes in this class. If you want also, for example, a no args constructor, means a constructor with no parameters, you have the no args constructor annotation. Also, if you need all args constructor, you can also add it using this annotation, also all args constructor. But we have another annotation, it's called data, always from Lombok. And if we go and read the documentation, always try to download sources to be more readable for you and to get all the information that you need. So here, this data annotation, it generates getters for all fields useful to string method, hash code and equals implementation, and so on and so forth. So this data annotation, it's the equivalent to getter, setter, required args constructor, to string and equals and hash code annotation. So always to reduce the amount of boilerplate code, we can remove this, and we can remove this too. So we can just work with two annotations, data and no args constructor, and also if you need other annotations, it's also easy to use. So we have now our class or our Java object ready to use. Let's move on and try to make this an entity or to make it a table. Now let's try to answer one question. Is having a Java class containing all the attributes that we need for our table, is it enough to tell Spring that this is an entity? So Spring or Spring Data JPA, how he will know that this is an entity and needs to be managed? So the answer, first of all, this is not enough. Having just a Java class is not enough. And we need to tell Spring that this is an entity. So we need to provide some annotations or some information in order for Spring to be able to scan and pick up this object. So I already told you the answer. So we need to give an annotation, and this annotation is entity. Okay? So this entity, just let me show it to you first. So now we are using Spring Boot 3.0, and as you know, one of the breaking changes, or like the biggest changes, is using Jakarta EE 9. And when we use Jakarta EE, so the package is no longer javax.persistence. So all the javax, not all of them 100%, but all the javax packages that belongs to the Jakarta EE, now they have been renamed to Jakarta. Okay, and from now on we need to use jakarta.persistence for all these annotations. Okay, all right. So here using this annotation, and when we run the application, automatically Hibernate, Spring, and Spring Data JPA, like all of them are working together, so they will be able to pick and tell this is an entity, so we need to use it. Okay, and I want to show you also the documentation, and it says that this specifies that the class is an entity. So it specifies that the class that has this annotation is an entity. Okay, and also this is so important, this annotation is applied to the entity class. So here it's a type level or type target. So like this, we covered this part, this entity part, and we have here the same package as we already saw together. So now Spring will be able to know or to recognize this author.java class as an entity. Let's move on and see what we need to provide as minimum information in order to have this entity created in our database. After annotating this Java class, this author Java class with the entity, so this means that Spring Data JPA will recognize this class as an entity, and it will create the table, for example, based on the configuration we specified in the DDL auto when we first configured the application. So it will automatically create this table. Otherwise, it will consider it as a table. All right. But here we see that we still have an issue. Even by having this entity annotation, we still see that we have some error right here. And let's go ahead and check it together. So here it says that the persistent entity author, so we see that now our class is a persistent entity, should have a primary key. So you may ask the question, I already have a key field right here. But yes, this is a key for us. We are a human being, and we understand and we can read that this field is ID, and even our intention is to have it as an ID for our entity. But Spring Data JPA doesn't understand this. Spring Data JPA is just a program. It's just 0 and 1 is a binary, so it understands only annotations. Okay, so to make this field an ID or any other field an ID, we need to add an annotation, and this annotation is as the name says, so it's the annotation ID. And here, while we are using the Spring 3.0, always make sure that you are using the annotation from the correct package. Okay, so the package is always jakarta.persistence. All right, I will insert this one, and we see that the error now is gone. But first, let me explain to you what is this ID. So in Spring Data JPA, the ID annotation is used to mark a field as the primary key of an entity. It is used to specify the identifier property of an entity, which is used to uniquely identify an instance of the entity in the database. Okay, so when the entity is persisted to the database, the value of this field will be used as a primary key of the corresponding database table. So this means the value of this integer ID is unique within our table, and also it might be unique within our database, depends on the generation type or the strategy that we will use to generate this ID. All right, so here I want also to answer one small question you might ask. So why we are using integer here instead of int? Okay, so the answer is as follow. So the int value by default is 0, but the integer value by default is null. And this is super important because Spring Data JPA, and when we talk mainly here about Hibernate, because we are using the Hibernate implementation. So Hibernate, each time when we try to save or to persist a new row or new line into our table, Hibernate will check the value of this ID or the field annotated with the ID. If the value is null, Hibernate will understand that we want to create or to persist a new element into the database. Otherwise, if the value is different from null or is not null, he will try to fetch the element within the table that has this value. Okay, so if we use the int, if we use the primitive type, so the default value will be 0, so Hibernate will try to find an element or a row with the value 0, and it will never find it. Okay, so that's why it's always recommended to use wrappers over primitive types. Okay, so I hope this is clear. If you have any questions, just go ahead, reach out to me. Otherwise, let's move on. We already explained that this ID is the unique identifier of our table. And we mentioned that we want to use, or we need to use, the wrapper classes or the classes like objects in here, because the integer is the wrapper class of the primitive type int. Because when Hibernate sees that this ID has a null value, it will automatically generate a new ID and insert a new line into our table. But how Hibernate will generate this ID? So here we talk about generation types or generated values for our IDs. And here let's explain, or let's see which annotation or which mechanism can help us generate this ID. Alright, so the answer is easy, and here we have an annotation called GeneratedValue, and just a reminder, always from jakarta.persistence. And once we mention, or once we annotate a field with this generated value, here let's check the documentation, what is written in here. So it says that it provides for the specification of generation strategies for the values of primary keys. So here this is a keyword, means that we work with primary keys. So this generated value works with primary keys. So the generated value annotation may be applied to a primary key property or field of an entity or MappedSuperClass in conjunction with the ID annotation. So this property or this annotation might work with primary key, property of a field, or an entity, or MappedSuperClass. We will see all these terms together, and always in conjunction with the ID annotation. The use of the generated value annotation is only required to be supported for simple primary keys. So we cannot use this generated value with complex keys. Complex keys means we can have, for example, an ID composed of two fields. Let's say, for example, an integer and a date. So this we can create a composed key, and we will see that also somewhere like after in this course. Okay. So use of the generated value annotation is not supported for derived primary keys. Okay. So here we have this annotation generated value, and we know that it will generate an ID or auto generate a value for us. Let's check what we have in here, or which properties we have within this annotation. So we have a strategy which is of generation type, and also we have a generator. So this strategy is the primary key, so it's optional, but it's the primary key generation strategy that the persistence provider must use to generate the annotated entity primary key. So here we can define, or we need to define which strategy we want to use. So the persistence provider, and the persistence provider here means the database provider or the database management system we are using, must use to generate the annotated entity primary key. So here we have a default value for this, and we will check what are the types we have right here. The second one, it's also optional. We don't need to specify this property, and this is the name of the primary key generator to use, and specifies the sequence generator or the table generator annotation. Defaults to the ID generator supplied by persistence provider. So here, based on the generation type that we want to use, we can also create our own generator. So this means what? Let's go ahead first and check these generation types. So for these generation types, we will go and understand them one by one. We have table, sequence, identity, and we have this UUI ID and this auto. Okay. All right. So we will understand this in a few seconds. And now I want to go back to this generated value annotation and talk about this generator. So we saw that within this generation type, we saw that we have one value called table and one value called sequence. So this sequence generator and table generator, they are responsible if we want to create manually our sequence generator or table generator. So we will understand that in the next lecture. So now let's understand the different types of these generation strategies. So as we mentioned, the default value of this generated value, the strategy, the default value of it is the auto, and we also have the sequence, table, and identity. So first, let's understand what this strategy equals auto means. So this means that Hibernate will try to connect to the database or to the persistence provider and try to determine which is the best strategy to use. So to understand this more in practice, so just a reminder, here we see that you have within this generated value annotation, we have the default strategy is auto. And now, in order to understand that, all we need to do is to start our application. So by default, our application is connected to PostgreSQL, and we will see that within PostgreSQL, it will choose one strategy, but when we choose MySQL, or we start with the MySQL profile, it will choose a different one. Okay, so let's go ahead and start our application. So our application has started, and let's check the log first, and then we will check the database. So here it's just a normal log and a classic one, but we see here we have some Hibernate logs. So now what we have create sequence, author sequence, start with 1, increment by 50, okay? And then we create a table author with the following attributes, integer ID not null, and so on and so forth. And we have here, or we are defining here, a primary key ID. Okay, so this is good. Let me reduce this, and here within this data JPA or our database, let's refresh it. And here, if you see 0 of 3, you need to select the public schema. Okay, now let's open this one. Within the public, we see that we have one table, which is our author table right here, with the fields or the columns that we defined, which is ID, age, email, first name and last name. And also we see that we have one sequence, which is the author sequence. So by default, Hibernate determined that the best strategy to generate IDs for this database, for the PostgreSQL database, is using sequence. So it created a sequence and it named it author sequence by default. Like it takes the concatenation of the table name within a suffix underscore sequence, and then it will use this sequence to generate values. So if we have multiple tables or like more than one entity, the sequence name will be Hibernate sequence. Okay, but for now we have on one single table, so it will take the table name with this sequence suffix. All right, now let's restart our application, but using the MySQL profile, and let's see what will happen within this MySQL. Okay, so let's do it. And in order to define the different profile, so all we need to do here within IntelliJ, you see this little caret right here. Just click on it and then open edit configurations. Select your application right here. So you might have multiple ones, but select the one JPA application. It's our application name, and here specify the profile name. And the profile name, how you can find it, let me close this one first, and you open here, and you see for here for our application, it's called application-mysql. so this MySQL is the profile name. So now let's go ahead, edit the configuration, and in the active profiles right here, I will just provide MySQL. So like that, when we start up the application, Spring will pick up this configuration file. So now the application is running, and we see that we have drop table if exist, drop table if exist. And here what do we have? Here we are creating first create table author with the attributes or the IDs that we precised. And we see here, instead of creating a sequence, we have create table author sequence. So it contains a next value attribute of type big int. Okay, so here MySQL and Hibernate determined that the best strategy for MySQL is using table, okay, using strategy table. And this might not be the best strategy, but maybe MySQL or any other database management system does not support one or another strategy. For example, MySQL does not support sequences, so it will fall back to the second option. Maybe I don't know the exact order, but I'm just trying to explain it like that. So it will fall to the next strategy, which is author, which is table strategy. Okay, so let's check our tables right now. Click here, refresh. And now we see that we have two tables. The one is our author with the 5 columns that we already precised, and the author sequence is only one column, which is the next value. So if I open this table, you see that for now it contains only one line and the value is 1. And if I insert any data, it will automatically increase it by 1 and use it for the next value. All right, so this is the auto strategy, and now let's move on and talk about the next one. So here we saw together how Hibernate is able to detect which strategy is the best for our persistence provider. Now let's talk a bit more in details about this sequence generation. Okay, so by default Hibernate will create a sequence if possible, of course, but let's assume that we are using PostgreSQL and the best strategy is sequence. So Hibernate will automatically create a sequence. But what if we don't have the right to create sequences? What if we have a database admin that creates everything for us? So we need to specify which sequence we have already, or like we need to point Hibernate to that sequence, and the name might be a different sequence, so we need to point Hibernate to that. So this is one use case. The second use case, I want to create my own the sequence, and I want also to auto generate or to auto configure manually the allocation size. So we saw in the previous lecture that Hibernate will use the value 50 as an incrementation or as a step value. So we want, for example, to be 1. All right, so let's see how we can do this. So now, in order to do that, first of all, we need to specify the strategy right here. And the strategy, if you hit Control Space, we see the options that we have, and let's choose sequence. Okay, now I just want to remind you that within this generated value annotation we have the strategy and the generator, and the generator here, it's the name of the primary key generator. All right, so let's give it right here. I will just put it into new lines, and here I will precise the generator, and my generator is a string, like we need to give it a string name, and I will call it author generator or sequence, author sequence. Okay, I will call it author sequence or let's call it sequence to see the difference between the one we generated before or that was automatically generated. I'm talking about this one, so our name would be author sequence. All right, okay, so now we have author sequence, but when we start the application, Hibernate will not find this author sequence, so it will claim, or it will raise an exception telling that we don't find this exception. All right, so what we need to do is we need to create or to manually create this sequence. Okay, and to do that, it's really easy peasy. We have an annotation called SequenceGenerator, and this annotation SequenceGenerator, it takes a name as a parameter. So this is the name, and the name should be the same like as this one. All right, so I'm just gonna copy paste it to avoid typos, and let me align it. So after providing the name, we need also to specify the sequence name. The sequence name is the sequence that also we want to use as a name. All right, so sequence name, by default it's empty, but let's also use this author sequence as a name. Next, we talked about allocation size, means the step of increasing or incrementing this sequence, and it's called allocation size. And as you can see here, the default value of this one is 50, and this is what we saw before in the logs. This is where this allocation size or 50 is coming from. All right, so for us, we want an allocation size of 1. And now that's it. We have our sequence generator and we have our generated value for this ID. Let's go ahead, start the application and see what will happen. So here we see that we have this log right here, create sequence, author sequence. So now it's called author sequence, start with 1, increment by 1. So it starts from the position number 1 and it's incremented by 1, and this start by 1, so it's from the initial value. So you can also change it if you want to start your sequence from specific value. All right, Next, we are creating the table, and now let's go and check the database and make sure that we have everything in order. So I will just refresh this one, and we see that we have our table, and now our sequence is called author sequence. So in case you want to create a specific sequence or a specific sequence for each entity, this is the way how to do it. All right, so now this is how sequences works, and then you don't need to do anything. Hibernate will automatically use this author sequence to generate the ID. All right, so that's it. If you have any questions, just reach out to me on contact@alibucoding.com, or all my contacts on social media. Otherwise, let's move on. Now, what if we want to choose a different strategy of generation? What if we want to use table instead of sequence, and we want to create our table generator instead of sequence generator? So let me show you how to do that. First of all, I will just comment out this sequence generator. I will leave it here in the code so you can use it. Then we need to change this generation type from sequence to table. And I will call or rename this generation or generator, instead of author sequence, I will call it author ID generator. Okay, so ID gen, I will call it like that. Okay, now instead of using this sequence generator, we have a similar annotation, which is table generator. Okay, this table generator, it takes a name as parameter. So the name, I don't need to mention it again, but it should be the same name as in here. After precising the name, I want to precise also the table, right? So the table right here, let's call it ID generator, for example. All right, next we need to precise the primary column name, comma here pk column name, and this is gonna hold the column name of our primary key. Let's call it ID name, for example, just to make it easy for you. I will call it ID name, and the value column name is the value for this column. So I will call it ID value, just to be consistent with that and make it easy for you. And of course, we can define the allocation size. As you can see here, it's always default 50, and I want to make it 1. All right, so I will keep the same profile, the PostgreSQL profile, so we can see the difference, or we can see what will happen when I restart the application. So I'm gonna stop it right now and restart it. So here, let's first check what we have as information. So we have here create table author. So this is our main table. And then we are creating a table called ID generator, and the ID name is type of varchar 255, and the ID value, and so on and so forth. So here what we are doing, insert into ID generator, and we are inserting the first value, which is the author, and the value is 0. All right, so let's check what we have in here. I'm gonna refresh this one. So here we no longer see this sequence generator right here. We no longer have the sequence, but instead we have this generator table, and this generator table, it contains only already one line, which is the author, which is our entity name, and the ID value is 0. So when we use this table generator, the one that we created manually, it will create one line for each entity, and it will initialize the ID value for it. So if we want to insert another entity, it will come here, query it by the name, and as you can see, the name is an ID, so it should be unique, and it will increment the value for that one. So this is how we can also use tables as generators. But here, before we finish this part, I want just to bring everything as it was before. So I will also comment this out just to leave it in the code. like that. And also I will change or just remove this. Okay, so I will just leave it as generation type auto, and like that I don't need to care about which strategy to use. All right, so that's it. If you have any questions, don't forget to reach out to me. Otherwise, let's go ahead and continue. In the background, I restarted the application, so we have the previous state. So now we have our table and we are using the sequence as a generator. So what I want to show you in this part is, as you can see here, we have this ID, age, email, first name, last name, and so on and so forth. But the question is, what if I want to have more control over these columns? Okay, so for example, this first name, I want to have a different name, and I want to have a different name for this last name. I want something which is different from the field that I have right here. So this is the first thing. The second, I want to have a unique, or I want to make sure that my email is unique. So this will prevent me from having duplications when we talk about email, because we know that an email is unique per user. All right, so to do so, we have an annotation that can help us reach this goal. So let me make this one full screen. And first of all, let's talk about this annotation. So the annotation is colon. And first, let's check what this colon is, what this annotation. So it specifies the mapped colon of a persistence property or field. If no colon, this is so important, if no colon annotation is specified, the value or the default value apply. So default value means what? Means the default values of this annotation, of this colon annotation. And let's quickly check the attributes that we have right here. So as you can see, all of them are optional here. So the first one, we have this name. So this is the name of the column. Otherwise, it will take the property or the field name. So if we don't precise anything in here, so the default name will be first name. And here, as you can see, that when you write it in camel case, it will be transformed automatically into snake case. All right, now let's go back to this colon annotation. We have a unique attribute. So this specifies whether the colon is unique or not. Also, if it's nullable, if we accept null values, by default it's true. But if we accept null values or not, and here we have this insertable property. So this means what? This means that if we accept that we can insert new value for this column. You may ask the question why I should prevent inserting. And the answer is, when we talk about, for example, dates, and we have an update date or the last modified date of this column. So here we don't want it to be insertable, but we want it to be only updatable. Okay, so here we have insertable true, updatable true, and the same for this updatable property. So for creation date, or like the date of creation of a new line, or when we insert a new row into a table, we want to track the creation date. So the creation date should be only insertable, and we need to insert it only when we create a new line. But when we update the same line, we don't want to update it. So this field should not be updatable. Okay. And here we have a table, we have length, and also length, for example, for strings, we can specify, or we can say, for example, that a username or a login name or a pseudonym should be only maximum, or have the length of 8 characters maximum. Okay. And when it comes also to numeric numbers or decimals, we can talk also about precisions and scale. So, okay, now we talked enough. Let's go and see this in action. All right, so for the first name, I want to have my name, or the name of this field, to be like that. For example, if name. All right. And why we have, or why we need to change this. So like For projects from scratch, it's okay because we will define everything. But imagine you want to work on a project where the database already exists. And for example, let's take the financial domain, and the database already exists, but believe me, you don't want to know how they call the fields or the columns. So it's totally different because they are using really technical names, financial technical names. So we want to have a more understandable for our Java application. We need to have a more understandable names. So we need to stick to the same names to the database, but we want to have our own. All right. So when we manipulate objects within our Java project, we want to use first name instead of this F name, or it can be F1234. So we don't want to name our field F1234. We want to name it first name, and then we can reference it, or we can give it a name that will be used within our database. Okay. So this is the first one. Now I will move on to this email. So for the email, for example, it's okay, it's fine for me to keep the name as it is, but for this email, I want, for example, I want it to be unique. So as you can see, and also as I showed you before, this unique attribute has a default value false. So by default, the field or the column is not unique, but let's make it unique. So when we use this property, this means that the email will become unique. So we cannot insert a duplicate values for this email. All right. Also, I can make it non-nullable, because also nullable by default is false, but I want to specify or like make the user pass a value for this email. So the email I don't want to see any emails into my database with null values. Okay. Also, if you want to, I know this is not okay, but let's go back and do it. In here, I was going to talk about the length. If I want to have a specific length, so the default is 255, and let's say, for example, I want to have 35 as max length for this first name. So this is the property to use. All right. So here, if we talk, for example, as we mentioned before, I will create a local datetime field right here, created at. So this is the creation date, and I will give it also the colon annotation. All right. And for this colon annotation, I want this to be not updatable. All right. So as you can see, it's by default true, but I don't want this field or this column to be updated. So I want it only to be insertable. So I don't need to specify the insertable because by default it's true. But I don't want this one to be updatable, and this one cannot be null. All right. So this also nullable false. Now I will create another column, and I will call it last updated at, or last updated, or last modified. Let's call it like that. So for this last modified, I will also use the colon annotation. And within this colon annotation, I want this one not to be insertable. So I don't want to insert this last modified when I first create a new line, or when I first insert a new line, I want this last modified to be null. So because if I insert it, it might be confusing, because for example, I want to query all the data where all the data that were not modified. Okay, so I don't want to insert it. All right. I want it also to be updatable, and it will be nullable. So I just keep the default value because nullable is by default true. So using this colon annotation, we can have more control over our columns within our entity and on the database level. So we can precise the name, we can precise the length, we can also check the unicity and the nullability of our field. Also, we can decide if it's updatable or not, and if it's insertable or not. So this annotation gives us more and more control over our our columns. Okay, so I'm gonna restart the application and let's see the impact of these annotations right here. So let's see what was the impact of this. So here it's just updating the constraint. So here we see that first of all we are adding a new constraint to our email with this unique. So now it's unique, and here, for example, for the age, it's an integer, not null. And we have this created at, it's not null. The email is also the same. And we see that the first name is now called fname and is no longer called first name. All right. So we see also that the last modified is a timestamp, but we don't have any control over it, like a not null and so forth. Same for the last name. And here we are defining the primary key as our ID colon. Let's see the changes directly visually. I will refresh this. And now we have our 7 columns. So we see here that we have this ID, the age, created at, email, and we see this small circle right here. So this means that these objects are not null, or they should not be null. Okay. Also, we see that we have 2 keys. So we have the author primary key, and we have a second one which is referencing the email, because we don't want this email to be null and we want it to be unique. So here you see this UK is unique, stands for unique key. PK stands for primary key. All right. So I hope this was clear for you. Otherwise, drop me a message and let's move on. Now let's take the following example. What if we want our table to be named author underscore TBL as a table name in the database, and we have our Java class called author. So in this case, how we can map, or how we can tell this entity or the Java class, or we mainly talking about Spring Data JPA and Hibernate, how we can tell Hibernate to name this entity and give it the name author underscore TBL in the database. So the answer is in here. We see this annotation. The table annotation is the one that can help us do this. So let's see the power of this annotation. So let's go back to the code right here, and now I will use this table annotation right here. So first of all, let's check what are the properties of this annotation. So first of all, it says that it specifies the primary table of for the annotated entity. Additional tables may be specified using secondary table and secondary tables. So here, if no table annotation is specified for an entity class, so the default values apply. So if we don't use this annotation, we will apply this default value. So the name will be empty, catalog, and so on and so forth. So let's now discover quickly these fields or these properties. So name, this is the name of the table. So we already have the answer how we can change or how we can give a specific table name. Here we can also specify a catalog, and the same for the schema. So for example, if my table is located in a different schema, so I can provide it in here. So I can give this information. So for example, if I have a schema 1, schema 2, and schema 3 within the same database, so I can specify, or I can precise which schema for each entity or each table. Also, if I have unique constraints like the one we did before, we want for example our email to be unique, we want to add new indexes and so on and so forth, so we can add a list or a table of unique constraints. Okay, the same for indexes. All right, let's go back here. So for our case, we only want, or we only need to give a name to our table, because we have only one schema. So if you have a different one, you can give also the schema name. So here I will call it author TBL, And I will restart the application and let's see the changes. So click on restart right here. And let's check again what we have. So we have this sequence, this author TBL underscore sequence, and we have our table now is called author TBL. Okay, so just for record, databases are not case sensitive, just in case you don't know this information. So that's why we see here that the table is written is lowercase, and here it's already in uppercase. So we see now that the table or the table name has changed, and now it's called author TBL. All right, so yeah, that's it. I will just clean up the code, comment out this annotation, and I will leave the rest for you. So thank you so much. Drop me a message if you have any questions. Otherwise, let's move on. So far, we learned how to manipulate data tables, how to create entities, which are the annotations that we need to use, which properties of these annotations we can use. Like, for example, when we talk about generated values, how and the strategies, how they work, how we can also customize them and create our own and private sequence and table generator, and so on and so forth. But now we didn't reach yet the point where we need to discuss or where we need to manipulate and interact directly with the database. Interact means, for example, CRUD operations like read, create, read, update, and delete. And this we will see right here. For example, we have, as always, our author table in the database. So this author table has its own representation in our Java code as an author.java, and we need to persist this object to this database. So the link between the author and the database right here, because the a table already belongs to a database. But when we talk about Java programs, and also when we talk about Spring Boot framework, we talk about entities. All right. So what we need to do in order to better interact with this database. So here comes the power of Spring Data JPA. So Spring Data JPA made it so easy for us because he proposed something really, really nice, which is a repository. And the repository is an abstraction to reduce the amount of boilerplate code needed to implement the DAO layer or the data access object to interact with the data stores. Okay, so let's go a bit deeper within this definition. So in Spring Data JPA, a repository is a Java interface that is used to abstract the data access layer from the business logic. It is used to perform CRUD operations. CRUD, just a reminder, stands for create, read, update, and delete, as well as other common database operations such as pagination and sorting. Repositories are typically defined as interfaces and that extend one of the Spring Data JPA repository interfaces, such as JPA repositories, CRUD repository, paging and sorting repository. So these are the three main repositories or JPA repositories that we can extend, like we create an interface and extend this interface to have our own repository. Okay, so because these interfaces provide a number of predefined methods that can be used to perform common database operations such as saving, deleting entities, finding entities by their primary keys, finding entities based on various criteria. And this is what we will see in details later on. Okay, but first, let's understand and see this hierarchy of repositories. So far, we learned how to create a Java class out of a database table, and this Java class is the representation of the table in our database. Now we have another question, is what can we do or how can we do when it comes to database manipulation and interacting with the database? Means if I want to persist a new object into or a new row into this author table, so how can I do this? So the answer is using JPA repositories, right? So, but first let's understand and give a quick definition of this repository. So a repository is an abstraction to reduce the amount of boilerplate code needed to implement the DAO layer or the data access object to interact with the data stores. Indeed, in Spring Data JPA, a repository is a Java interface that is used to abstract the data access layer from the business logic. It is used to perform CRUD operations such as create, read, update, and delete. So this is what CRUD stands for. And then as well as other common database operations such as paging and sorting. So repositories are typically defined as interfaces that extend one of the Spring Data JPA repository interfaces, such as CRUD repository, paging and sorting repository, or JPA repository. So this has been a bit changed since Spring 3.0, and I will show you the difference right now. So these interfaces provide a number of predefined methods that can be used to perform common database operations, such as saving and deleting entities, finding entities by their primary keys, finding entities based on various criteria, and so on and so forth. And we will see in deep how we can create data or can create queries using the Spring Data JPA repositories. So, but first, let's understand or see the hierarchy of the Spring Data JPA repositories. So as we can see here, that's why I told you before that it was slightly changed about when we talk about paging and sorting repositories, because now the new architecture looks like that. So we start, as we mentioned, by creating an interface. So for our example, we want to create an author repository, and then we need to extend one of these 5 repositories that we see right here. All right. But let's start and see the inheritance from the lower level, from the lowest level to the from the highest level to the lowest one. Actually, it's the other way around. So we first can start by extending JPA repository right here, and this JPA interface repository, it also extends 2 other interfaces at the same time. So it extends the list paging and sorting repository and list CRUD repository. So this list CRUD and list paging, so both of them, they contain methods. Like this is where comes the difference, because there have been a small refactoring in these interfaces. So now we have all the methods that returns list. They are within this list paging and sorting repository. So this in order also to reduce more the boilerplate code, because for example, if I want only to perform CRUD operations with I don't need list, so I can only extend this CRUD repository. Same for paging and sorting. But if I want everything, all I need to do is extending this JPA repository. So let's continue. So here we see, or we said that the JPA repository extends at the same time list CRUD repository and list paging and sorting repository. And the list CRUD repository already extends CRUD repository, and this CRUD repository also extends the basic interface which called repository. The same way when we take the left hand side part, so when we talk about JPA extending list paging and sorting repository, this interface itself, it also extends the paging and sorting repository. So now let's go ahead and see the code, or the not the implementation, but the interface which was created by Spring Data JPA. So go back to your IntelliJ, hit Command-Shift-O or Control-Shift+N for Windows and Linux users, and just type JPA repository, and you will see that we can open the Java class or the repository if you already downloaded the code. and we can open it, and it's the one Spring Data JPA, the version 3.0.0. So if you are using a previous version of Spring Boot, this might be slightly different, okay? But our course is fully focusing on Spring 3.0 because we want to see the new changes and we want to use also the most recent versions. All right, let's go back in here. So we see that we have here our JPA repository interface, which is extending at the same time list CRUD repository and list paging and sorting repository. So this query by example executor, so this is something else we will see later on. So that's why I didn't mention it in the diagram. So let's go back and focus on this. So here we have this list CRUD repository. If we open it, we see that this list CRUD repository is already extending the CRUD repository, and list CRUD repository contains all the listing methods. So save all, find all by ID. And then when we open this CRUD repository, we see that it also extends the repository interface, and this CRUD repository contains these methods like the CRUD method save all, find by ID, and so forth. All right. And the same way, if we want to go to list paging and sorting, so here we have this find all within this list paging and sorting repository. The same when we go to the paging and sorting repository interface, we see that we have this find all, and so forth. And this one, like we see when we talk, because when we talk about paging and sorting, we mainly talk about lists. So we have here the first parameter for the find all is a sort, and the second one it's a pageable, and the pageable also contains the sorting. So we can, if we want to use this one, so it already covers this. All right, but make sure that the return type of this one is iterable and this one is page. So this is just to mention. And as we said, both of them, they extend the repository interface. All right, so if you have any questions, don't hesitate to drop me a message. Otherwise, let's move on and continue. First of all, we will create a repository for this author model or this author entity. But first of all, don't panic if you see that I removed the code. And don't worry, you will not be losing the code because here it's just a cleanup, and you can find all the code when you go to Git right here and then you click on the logs. You will see that after each chapter, I will commit or have a full commit right here. So if you double click on this author, you will see all you need. So here you have the entity, you have all the annotations, the strategies, and so forth. So you will see all the changes that we will do in each chapter. So don't panic, don't worry about that. So it's just for me to have a clean code for each step. All right, so now in order to create a repository, it's so easy. So here I will create a new package, or I can create a class and a package at the same time. So here, create a package, call it repositories, and then dot, and the class name or the repository name. And don't forget to select interface, because we mentioned that a repository is an interface that extends another interface, one of the JPA repository interfaces. So let's call it author repository. Hit enter. So here we see that we have a public interface author repository, and in order to transform or to tell Spring that this is a JPA repository, we will need to extend one of the repositories, okay, the repository interfaces. So for our case, we will extend the JPA repository. So because within JPA repository, we have all the methods. And as we saw before, this JPA repository, it's a generic interface that takes two types. The first one is T, which is the class or the table. And the second one is the ID. And this is the unique ID or the type of our ID within our entity. All right, so if here it's integer, so we will pass integer. If you use string, long, big decimal, and so on and so forth, just pass that type. All right, so let's finish this one. So it's a repository or JPA repository of our object author. So this will help Spring Data JPA to determine and correctly write the correct queries. Okay, and of course we want our ID, which is of type integer. Okay, so like this we have our first repository. Now let's go ahead and play a little bit with this repository and create or insert some data and see how we can use this repository. Now, in order to test this repository right here, we need to create a service and then create a controller, expose the endpoint, and use Postman or like use Swagger UI to test this repository or test these methods and so on and so forth. So the process might be a bit long, but let me show you a better way how to do it. Okay, so we will use a command line runner, and the command line runner is a bean or is a method that will be executed at the application startup. Okay, so when we first start the application, we will run this method, and within this method we can inject any bean which is available within our application context. All right, so to do so, let me close all this, go to the JPA application or your main application file, the one where you have the Spring Boot application, because this is the startup class, and then just create a bean. All right, so add the bean annotation, and here a public beans should always be public, don't forget that, and the type is command line runner. All right, so this interface right here, command line runner, give it a name, command line runner, and within this command line runner method or bean, you can pass any type you want right here. Okay, so it's like that, and now I want to inject my author repository right here. Okay, so I will create an object of type author repository. I will call it repository as a simple name. So like this, automatically this bean or this author repository will be injected. Okay, so now to implement this, let's use a lambda expression. So let's say return args or something like that, and then arrow function, and that's it. And inside this method we can implement or we can do whatever we want within this repository. Okay, so let's go back, check quickly our author method. So here we have the data, no args constructor, entity, and so on and so forth. I will just add two annotations. The first one is all args constructor, to have a constructor with all the arguments, and the other one is the builder annotation. So the builder annotation, it's for the design pattern builder, which help us create and building objects. So I will show it to you right away. So now to use this builder annotation or this builder design pattern, I will create a var, call it author. So you can use var because we are using Java 19. So equals author dot builder dot build. So you see, because we have this author, because we have this builder annotation, now we can use this build or builder method. So you see already in the icon right here, this is the Lombok icon, and yeah, so and then I will just type build. All right, so this builder help us, like we can use the field names as methods, so first name, email, and so on and so forth, to create or to instantiate an object. All right, so let's have first name, I will call it Alibu, last name also Alibu. Let me make this one full screen. Age, okay, I'm gonna give you my age, I'm getting a bit old. Okay, so email, here you can find my email if you want to contact me. So it's contact@alibucoding.com. And that's it. So these are the information that we need to create an author object. Now let's use our repository dot save. Right, so within the repository, let's go ahead and have a quick look on the methods that we have right here. So we have save, count, delete, equals, delete all by ID. So all these methods, they come from all the interfaces that we saw together. So like we have a pre-built methods that we can use without any need to create methods our own, like, or to type or create queries manually. So we can use Spring Data JPA or the repositories to create a bunch of methods or many methods that can make our life so easy. So for now, I want just to test the save method. So I want to save this author object. Okay. So at the application startup, when I run the application, this bean will get executed and it will insert a data or a line into the database. Okay, so let's start the application and test this one. All right, so the application is running right now, and let's first check the logs. We see that we have a first log from Hibernate, which is select next val from author seq, or like this is the sequence. So Hibernate will get the sequence or the next value from our author sequence. And then we see that we have an insert into author, age, email, and so on and so forth. And here we have the values. So here it's like just interrogation mark because it will not print out the execution, but here it's logging already that we are inserting something into the database. Now let's open our database and check that we have our data. So I will open this author table. First, let me refresh because we renamed a few stuffs. Yeah, now we have our author table. Go ahead, open it, and we can see right here that we have this ID, we have the age, email, and so forth. So here, like the object, he got executed, this bean got executed, and now we see that we have some data within our database. So also this might be useful for you if you need to execute something at the application startup. You can use this command line runner. So we will be using it in the future, maybe to test a few things. All right, so yeah, that's it. Let's move on now and answer one small question. At the application startup, when we execute this block of code, or when we execute any kind of this code in service or in a controller or whatever, so I mean when we create an object and we try to make a transaction to our database, saving it, deleting it, reading, and so on and so forth. So we call this a transaction. But this is not the main goal of this part. But first of all, we want to understand what is the life cycle of an entity. Okay, and to understand this, let's go ahead and open this diagram right here in order to understand what is a life cycle. Okay, so in Hibernate, an entity is an object that is persisted to a database table. And the life cycle of an entity refers to the entity, to the different states that it can be in during its existence, from when it's first created until it's eventually removed from the database. All right, so let's go and check these 4 states of a Hibernate entity. Okay, so the first one here, we have the first state, which is the state transient, and this is the state of an entity when it has just been instantiated and is not associated with a Hibernate session. An entity in this state is not persisted to be the database and is not managed by Hibernate. This means what? Means when we have or we create a new instance of our author object, or we use the builder for that, so we move from the object to a transient object right here. So at this level, our object is still transient. It's not persisted and it's not yet managed by Hibernate. But once we execute one of the following methods, save, persist, save or update, so like this, we will move from the transient state to the persistent state. So the entity or this object will become a Hibernate managed object. All right? All right, let's talk about and explain this persistent state. So this is the state of an entity when it's associated with a Hibernate session and is being managed by Hibernate. An entity in this state is persisted to the database, and any changes made to its properties will be persisted to the database when the transaction is committed. So here, when we do or when we operate any kind of this operations right here, so the state will become persistent, and any updates, so if we make any updates to this author object and we execute one of them, so this change will be affected or applied to the database once the transaction is committed. All right, so now after this persistent state, we can move whether to the removed state or to the detached one. Let's talk about the detached state first. So to detach an entity, the detach is this state of an entity is when it was previously associated with a Hibernate session, but is no longer associated with it. All right. And an entity in this state is persisted to the database but is not being managed by Hibernate. Any changes made to its property will not be persisted to the database until the entity is reattached to a Hibernate session. So let's focus on this until the entity is reattached to a Hibernate session. So this means what? Once we execute one of the following methods, detach, close, clear, or evict, the state of the Hibernate entity will pass from persistent to detached. Okay, and here when the entity is detached, we have two choices. So the first one, we can go back to the persistent state, or we can just go to the garbage. This object will just move to the garbage right here. Okay, but let's first talk about this word that we said, until the entity is reattached to the Hibernate session. To reattach the entity to the Hibernate session, we can use one of the following methods: save or update, merge or lock. So this means what? Means within one method, we can save, we can create the object, so it moves to the transient, save it, so it goes to persistent, and after the persistence or after saving the entity, we can do some logic, and then we call the session, the Hibernate session .detach, so it will move to the detached state. Once it's detached, we can also change some properties, for example, and then we can call back this one of these methods, save or update, and so forth. So it will go back to this persistent state. If not, or if we don't execute one of these methods, so the entity will just go to the garbage. So it will no longer become a Hibernate managed entity. Okay, so now let's go back to this persistent state. So from this persistent state, we can move to this removed state. All right. So to move from persistent to removed, we need to execute a method or a delete method. All right. So the removed is the state of an entity when it has been deleted from a database. An entity is in this state, so in this state removed, is no longer persisted to the database and is not being managed by Hibernate. So once we delete an entity, so it passes to the state removed and then automatically to the garbage. Okay, and here let's talk about a little bit and explain this state or moving the object to the garbage. As you can see right here, if we create an object, it's in the transient state. So from the transient state, it will move to the garbage if we do not execute any of these methods. Okay. Once we persist an object and then we try to detach it, and then we do nothing, it will also go to the garbage. Okay. Again, from this persistent state, once we perform a delete operation, it will go to removed state. So the state will become removed and then it will move to the garbage again. Now we can go here from this state, from this author, directly to this persistent state. So this means what? This means when we try to perform a get operation, find all, find by ID, and so on and so forth, so we will directly go to this persistent state. So because here we don't need to instantiate any kind of data, but we just want to call our session management or persistence entity or entity manager to get or to fetch data directly from the database. So we move from this initial state directly to a persistent state, and then we can move to these different other states. So we can perform a detach, save, delete, or remove. All right. So this is the Hibernate entity lifecycle. But here's something really important to know about. So with using Spring Data JPA, we no longer need to care about all this lifecycle because it's automatically managed, first of all. Second, so this save, persist, detach, and so on and so forth is being handled in the background. So we don't need to automatically commit the transaction or detach the entity and so on and so forth, because Spring Data JPA will do the job for us. So now we know and we understood what is the life cycle of our entities. Let's move on and explore other important things. If you have any questions, as always, do not hesitate to drop me a message. Otherwise, let's move on. Previously, we've been playing around this author entity. Now, what about if we talk about this whole class diagram and how we can realize it? Okay, but before that, we see that we have relationships between the different entities. We have the many-to-many, one-to-many, and so on and so forth. But first of all, what is relationship and why we need relationships? In a database, relationships between entities can be used to represent the connections and dependencies between different pieces of data. And there are several types of relationships that can be created between entities, such as one-to-one, one-to-many, and many-to-many relationships. Creating relationships between entities allows you to model the real-world relationships between different pieces of data more accurately, which can help you better understand and analyze your data. It can also help you to enforce data integrity and prevent inconsistencies by ensuring that changes to related entities are coordinated and consistent with each other. In addition to modeling real-world relationships, creating relationships between entities can also improve the performance of your database. By using relationships, you can avoid storing redundant data in multiple tables and instead use foreign keys to reference related data in other tables. This can help to reduce the size of your database and improve query performance. Overall, creating relationships between entities is an important part of designing a well-structured and efficient database. It can help you to model real-world relationships more accurately, enforce data integrity, and improve the performance of your database. So when you work with SQL databases, always think about adding relationships. This is important to improve everything and ensure integrity or your data integrity. Now, before moving on and start implementing this class diagram and creating relationships between the different entities, let's explain one small thing. So here we have, for example, this course entity and this author. We see that we have one relationship here. It's many-to-many relationship because we said that an author can create multiple courses and one course can be created by multiple authors. So that's why we have the many-to-many relationship. All right, so here we have a question. This question is, how can this relationship be done? And the answer is, here we are not talking about annotations, we are not talking about anything, but the focus or the main focus in here is the type of the relationship. So here we can identify two types. We have a unidirectional relationship. This means that one entity has a relationship with another entity, but the other entity does not have a corresponding relationship within the first entity. This means that the relationship is defined only on one side of the relationship. This means what? Like when we talk a bit code right now, this means when we create, for example, the course entity, and we want to link this course entity as a many-to-many relationship within the author. So we create an attribute or a list of authors within the course entity and give it the annotation many-to-many. And that's it. So this is what we call a unidirectional relationship. So it's from only one side. Now, what if we want to make it bidirectional? So in a bidirectional relationship, both entities have a relationship with each other. So this means that the relationship is defined on both sides of the relationship. So first of all, we created a list of authors right here, and it's referencing the author. Now, to make it bidirectional, we need to create a list of courses in the author entity right here. So like this, we will ensure that we have a bidirectional relationship. In general, unidirectional relationships are simpler and easier to understand, but they do not allow you to navigate the relationship in both directions. Means you can navigate from course to author, but if you implement unidirectional relationship, you cannot navigate from author to course. So it only ensures one-way navigation. But bidirectional relationships are more powerful and flexible, but they can be a bit more complex and require more care to maintain the integrity of the relationship. That it also ensure a bidirectional navigation from both sides. So from author, we can access the courses and vice versa. Now let's move on and start creating all these classes. Let's create and implement everything we have right here. Let's start now by creating our entities. So what we will do is we will create a Java class and give it the entity annotations for each of these classes that we have right here. But we will not do any mappings, any relationships. We will just create Java class course, for example, with an ID, title, description, and so on and so forth. So this is what we will be doing right now, and then we will move on and implement and explain in details all these relationships and annotations that we can use. So let's go back to our IntelliJ. I will close all these tabs, and within our models package, I will right click and create a new class. I will call it course. So here, like as we did with this author, we can use the same annotations right here. So we need the data, no args constructor, or all args constructor, the builder, and especially the entity annotation, because we need it to make the class or the course.java class an entity, but just I will copy paste them to make it much faster. All right. So this course right here, let's go ahead and create a few fields. We have an ID, we have a private string name, and we have also a private string description. And that's it. So here we have our entity. Next, let's add the ID annotation because we need it. And we have also the generated value. And just a reminder, always make sure you use the jakarta.persistence if you are using the Spring 3.0. Otherwise, it's still javax.persistence for the previous versions. So generated value, and we will leave the strategy to Hibernate to decide which strategy is better for us. Next, let's create the section entity. So I will call this class section, paste the same annotations we used before, and now we need to create a private integer ID and private string name, the section name, and also a private int order. So we want to give an order for each section. All right. Okay. Now, as always, we need this ID annotation and we need this generated value annotation right here. Okay, so that's it within this section entity. Let's move on and create the next one. Let's now create the lecture entity. So right click right here, new class, and call it lecture. As always, just paste the annotations that we will need. And now let's create an integer ID attribute. And then we need also the private string lecture name. So that's it. We have only an ID and a name within the lecture. And now let's add the ID annotation and the generated value. So this should be an easy task for you. And let's move on and create the next one. Now we will create this resource entity, but for the moment we will not create this inheritance video file and text, but we will leave it for later when we will explain the inheritance within Hibernate. All right, but for now, let's just stick to this resources entity and create the following attributes. So go ahead, right click on the models package, create a new class and just call this one a resource. Always paste the annotations, and we have here a private integer ID, private string name, resource name, and private int size. And we have finally private string URL. So this represents the URL of the resource. And do not forget the ID and the generated value annotation. So that's it. Now we have all our entities created. Let's now move on and start implementing the relationships one by one. Now let's start establishing and creating relationships between our entities. So let's start from here. Let's create the many-to-many relationship between the author and the course. And as we explained before, an author can create multiple courses, and one course can be created in collaboration of multiple authors. That's why we have the many-to-many relationship in here. Now let's go back to our entity J. And as we mentioned before, when we talk about many-to-many relationships or many relationships, the first thing that we need to think about is creating lists. Okay, so let's open our author entity and scroll down here, and first of all create a private list. The list is always from the Java util package, and we want to create a list of course. Okay, and let's call it courses. So this is the first step. Second step, go also to this courses entity, and in here create a private list of authors. Okay, author, and let's call it authors. All right, so this is the first two steps. Next, we are talking about many-to-many relationships. So let's add many-to-many right here, and many-to-many also on the course level. So now we defined, or we have our many-to-many relationships, okay? But now we need to define something. We need to define the owner of this relationship. So because we have the owner and the reverse relationship. And in many-to-many relationships in JPA, one of the entities is considered the owner of the relationship and is responsible of maintaining the foreign key values in the join table. And the other entity is considered the inverse of the relationship and does not have any foreign keys in the join table. All right, so to do so, once you decide which of them should be the owner of the relationship, just go to the other one that you wanted to be the inverse relationship and give it the MappedBy attribute, like give it the value. All right. So for our case, we want the course to be the owner of the relationship. So the author is the inverse relationship, right? So within this inverse relationship, add this MappedBy, and the MappedBy should be, or we should provide the name of the attribute we have right here. So here it's called authors. Just go copy and paste it in here. Be careful about making typos. All right. So if you make some typos, this means that you can also have exceptions at the application startup. Okay. So now let's go back to the owner of this relationship. So for our case, the owner is the course. And now to define the join table of this relationship, we define it from the owner side. So here we will use this join table annotation, and here this means, or this has a goal of creating a new joining table between our author and courses. Okay, so for this join table, let's provide some properties. First of all is the name. The name will hold the name of the join table. Let's call it authors courses. Means the courses of authors, or like you can call it whatever you want. Next, we need to define the join column. And here we can define multiple join columns. Okay, so the join columns right here equals, and now we need to pass a list of join columns. I will just make it a new line so it will be more readable for you. And now we will use the annotation join column. Okay, it's always Jakarta package. And for this join column, we need to provide the name, and the name right here, let's call it. So this join column is the one responsible, or the one that will hold the information or the primary key of the owner of the relationship. So this one will be the course ID. Okay. Next, once we define the join columns, we need to define the inverse join column. So when we say inverse, we are talking about the inverse entity. So here, inverse join columns right here equals, and as the same way, here we need also to use at join column. So join column, and let's give it a name. And here let's call it author ID. So like this, or in this way, we just defined a many-to-many relationship between our author and course. And to check that, let's just restart the application and see the impact in the database. And also let's check the logs. So here we see, all right, so here we have one exception, and you see right here, because it's caused because of this syntax error near order, because in this lecture, in this section, the order is a reserved name. Okay, so let's just rename it to section order, right? Or position or something like that. Let's restart the application again and see what happens. All right, so let's first check the logs. Here we have everything is working fine. And here we are creating the sequences for each entity. You see that for each entity we are creating a sequence. And here we have the author. We are creating the author and the course. And also we are creating the author's courses, the join table that we created for this author and course entity. We have also the lecture, resources, and so on and so forth. And here we are creating all the constraints. All right. So, and also here we are inserting, because we still have this bean right here. So if you want to stop it, just comment this bean out. Comment this out and it will no longer insert data. So now let's go and check our database. So here, refresh it. And now we should see at least the author, course, and courses. So here we have our columns. So we see that we have this ID, age, email, and so on and so forth from the author, and we have from the course, we have these 3 columns that we just defined: ID, description, and title. And now from the author courses, we see that we have 2 columns, and you see for the primary keys, it's a golden key, but for foreign keys, it's blue key. So now we see that we have this course ID, which is referencing the course, and the author ID, which is referencing the author entity. All right. So this is how we can create many-to-many relationships. Let's move on and see how we can implement relationships between the other entities too. If you have any questions, don't hesitate to drop me a message. Otherwise, let's move on. At this level, let's implement the relationship between the course and the section. So a course has 0 or many sections, or one or many sections, okay? And one section, if we take one section, it belongs to only one course. So here we have one course to many sections, and we have many sections to one course. So how we can also explain this? So when we create a course, we have the course, but every time we create a new section, we will have a foreign key course ID that will be associated within this section class. All right, so let's see now how we can implement this. So at this level, we are talking about the course. So, and we said that one course has many sections. So here, when we say that, we have one course and many sections. So list of sections, and let's call it sections. Okay, so this is the first step, because we have one-to-many. So it's always the current instance or the current object, which is the course, has many sections. So we create a list of sections right here. Okay, now let's go to the section. You can do command click or Control B for Windows and Linux to navigate to the definition of this. So here we said that many sections can figure out, or many sections belong to one course. All right. So here this means that we need to create a private course element right here, or a field of type course right here. Let's call it course. Okay. Now to implement the mapping, so we go back to this course.java where we have the list, And it's easy, like when we have the list, always think about one-to-many. So it's just as we explained it, it's one course to many sections. So one course to many sections. All right. And here, when we use one-to-many, we need to map it or to tell which mapping that we need to use. So here, MappedBy. And this MappedBy, it should be the exact same attribute name we have right here. So just copy, paste it, and be careful always about typos. So here we have this one-to-many. Now let's go and navigate to the section entity. So within the section right here, we said that many courses or many sections. So we said that many sections, they belong to one course. So we have ManyToOne. And when we use ManyToOne, we need to specify the join colon. So when we create a course, when we create a section right here, what should be the join colon name? All right. So here we need to add or to use the annotation join colon, and let's give it a name right here. And the name, let's call it course ID. Okay, so now we just created a mapping or a relationship between the course and the section. So let's restart the application and see the changes. So the application just started right here, and we see that we have all these entities. Now let's go and check our database. And now what I'm expecting is to see a foreign key called course ID within this section class. So let's do it, refresh the table right here. And let's check this section. So within the section, we have 4 columns. This is good. And we see that we have one foreign key. And this foreign key is this one. So we see it's FK. Let me make it a bit bigger. So we see that this FK stands for foreign key, and this is the ID of this foreign key. So the name or the key of this attribute is course ID, and it references to the course. Okay, so it references the course ID that we have within this course table. Okay, let's also check again the columns right here. So we see that we have an ID, name, section, and course ID. So like this, we are able to create or to make a relationship between two entities using one-to-many. Okay, let's move on and implement the next. And if you have any questions, don't hesitate to drop me a message. Now let's implement this relationship between the section and the lecture, and it's also one-to-many as we did for the course right here. So this, I think it's an easy task for you, and let's go ahead and implement it quickly. So from the section level right here, we said that the section has a list of lectures or many lectures. So let's go ahead, create private list lectures. Okay, and let's call it lectures. And now let's move to the lecture and create or reference it within the object that we have. So here we have private section, and now let's add the mapping. Okay, so we said that we have one section to many lectures, and this one is mapped by section. Okay, so it should be, just a reminder, it should be always the same name that we have here. Now from the section level, as we explained before, it's one section to many, it's one lecture to many sections, and here many lectures can belong, or they belong to one section. Okay, so here we have ManyToOne, and do not forget to add the join colon and give it a name, and let's call it section ID. All right, so that's it. Let's restart our application and check the diagram and check that we have all the foreign key correctly created. And here, if we go to this lecture, I'm expecting to have this foreign key right here, which is section ID referencing the section. And also for the columns, we have the ID name and the section ID as a foreign key right here. So that's it. Let's move on and implement the one-to-one relationship between the lecture and the resource. Now, when we talk about a lecture and a resource, we talk about a one-to-one relationship, because one lecture has only one resource, and when we talk about one resource, it belongs only to one lecture. So that's how, or that's from where we got the one-to-one relationship. Okay, just as a reminder, this part we will see later on. Now let's go back to our code. Now, in order to implement a one-to-one relationship, so first of all, define your entities, and in here we have our section, and also we have our resource. So from the section level, let's create a private resource. Let's call it resource. Okay, so when we talk about one-to-one relationships, we can talk about one unidirectional or bidirectional mapping. Okay, so we can link the lecture to the resource, and that's it. So we will have the owner of this relationship is the lecture, and we can access the resource from the lecture. But when we want to go back or access the lecture from the resource, we will not be able to do that because we don't have a bidirectional relationship. So let's start with unidirectional relationship. Now, in order to define a one-to-one relationship, as I mentioned, create an object of the other entity. So in our case, it's an object of type resource. And here we need to use the one-to-one relationship. Okay. So here we have the one-to-one. We can also define the join column name that we want to use. And here, let's say resource ID. All right, so this is how we can define a one-to-one relationship. And then let's restart the application and see the impact of this. So now we see that the application started. Let's check the database. Now, if we go to the lecture, we see here that now we have two foreign keys. The first one is from the resource, the one we just created, and the second one is the one we previously created from the section. But here we need to focus, or we want to focus on this resource ID from the resource. Okay. Also, if we open this one, we can see that we have a new column defined here, which is the resource ID. Okay. Let's go now and implement the second way, or like the bidirectional one-to-one relationship. So just to make it faster, I will just copy these annotations, go to the resource entity, and as we did before, let's create a private lecture, and let's call it lecture right here. Okay, and now let's paste this one-to-one annotation and join column, and this one, let's call it lecture ID. So here, this means when we want to create a new lecture and a new resource, we need to link them together in order to have this bidirectional relationship. Okay, so as we mentioned before, like having bidirectional relationships make it a bit complex to maintain all the foreign keys. All right, so let's go back, restart the application, and check the database. So the application is starting right now. Let's open the database and see. Refresh it. And let's see now from the resource, we will see that we have a new foreign key, which is the lecture ID, and it's referencing the lecture right here. So like this, we just created a one-to-one relationship between lecture and resources. All right, so that's it. We just implemented all the relationships between all our entities and classes. Let's move on, and I want to show you how you can check that what you created is the same as your class diagram. Now, for the people having the ultimate version of IntelliJ and using this database to check the data and refresh the data, and refresh the database and check the tables, so there is one thing that we can do. So here, when you click on this database, you can right-click on it, and here we have in the bottom you have diagrams, okay, and you can show a visualization or you can show it in a pop-up. Let's show the first one, and here it will generate all the tables of our database. Okay, so you can also click on this icon to apply the current layout, and it will reorganize it. And here we see that we have our author. Right here we have our author table. Let's just try to organize it a bit, and we see right here within this diagram that we have the same one as we already designed at the beginning of this course. So we have the course and the author, and here we have the joint table between these two one because we have a many-to-many. We also have a relation between our course and section, and the same between section and lecture, and we see that we have this one-to-one relationship between our lecture and resource. All right, so like this, or this tool might help you checking if you have the correct implementation or if you did the correct implementation or not. So just go ahead, use it, and you can also compare it with this diagram that we just created. So just double checking, we have author, courses, section, lecture, and resources, and it's the same diagram that we have generated right here. So this one, it will use the database and all the relationships that we already defined to draw this schema. So that's it about all the relationships. Now let's move on to a bit more deep and important stuff that we need to learn together. If you have any questions, don't hesitate to drop me a message, send me an email, or contact me on social media. And also you can go and ask your question on Discord. I will create a special channel for this course, so just go ahead and ask it. Otherwise, let's move on. Previously, we said that we will leave this part right here where we have this resource, video, file, and text entities to a further part. So now it's the time. So here, as we can see, so this is the symbol of inheritance, and we have this resource class. We have also these three classes, video, file, and text. So this means what? This means that a resource can be at the same time can be whether a video, file, or a text. So here we have video extends resource, file also extends resource, and same for the text. So in Spring Data JPA, you can use inheritance to define a base class of your entities and then create a subclass that inherit from the class or from the base class. So this can be useful if you have a number of entities that have some common properties and you want to avoid duplication code or duplicating the code. Okay? And when we talk about inheritance in Spring Data JPA, there are several ways to implement this inheritance. So we have the single table strategy. Also, we have the joint table strategy and table per class strategy. So we will see all of these strategies in details. But here we need to talk before we go and before we leverage inheritance, we need to talk about pros and cons for each one, for this inheritance. So the pros or the advantages of inheritance is, first of all, code reuse. So because inheritance allows you to reuse common code among multiple entities. Also, simplified queries. With inheritance, you can create queries that span multiple entities without having to write separate queries for each entity. Now let's talk about the cons or the disadvantages of inheritance. So first of all is the complexity. Inheritance can make the database schema more complex, especially if you are using a strategy like join table per class or table per concrete class. Also, we can talk about rigidity because inheritance can make it more difficult to change the base class or add new subclasses because it can affect the entire inheritance hierarchy. So this means every time you need to add a field or you need to add a new attribute within the base class, you need to really be careful about the subclasses or the derived classes that extends this base class. So this is mainly the pros and cons of inheritance. Before we move on and start implementing the inheritance strategies, I want to highlight something which is really important, which is composition over inheritance. Because both inheritance and composition are ways to achieve code reuse and modularity in object-oriented programming. In general, it is recommended to favor composition over inheritance, as composition is more flexible and easier to change. Because inheritance involves creating a subclass that is specialized version of a base class, so the subclass inherits the properties and behaviors of the base class and can also have additional properties and behavior of its own. This can be a useful way to share code among multiple classes, but it can also make the code more rigid and difficult to change. If you need to make a change to the base class, it can affect all the subclasses that inherit from it, which can be difficult to manage. Composition involves creating a class that has reference to one or more subjects and delegate tasks to these subjects. This allows you to combine the functionality of multiple classes into a single class without the inheritance hierarchy of a base and subclass. Composition is more flexible than inheritance because you can change the object that a class delegates without affecting the class itself. So in summary, it is generally recommended to use composition over inheritance because it is more flexible and easier to change. However, the best approach will depend on the specific needs of your application. So this is the comparison between inheritance and composition, and as I mentioned, it's always recommended or generally recommended to use compositions over inheritance. Okay, now let's go and dive into these inheritance strategies in case you want or in case you need to use inheritance within your application. So let me teach you how to use it in the correct way. Now imagine with me that we want to add some auditing fields to our entities. Means I want to add some information to track the creation and the last modification of each entity or of each line of my tables in the database. This means for example, this course entity or this course class, I want to add 4 fields like the created at, last modified at, and also created by and last modified by. Same for author, section, lecture, resource, and all the tables that I will create within my database. Okay, so in this case, I will have 4 fields, including this ID. We can count 5 in each entity, but this is okay from the database. But now when we talk about the code, our code, I want to avoid this code duplication and I want to organize it much better. Okay, here we can use one technique to achieve this one, and it's gonna be something like that. We will have a kind of base entity, or we can call it abstract entity or parent entity. You can call it whatever you want, and in here we will move, or we will try to collect all the common fields between the entities we have, or between the Java classes we have. And for example, we have this created at, last modified at, created by, and last modified by. And I want all these fields to be part of all the entities I have within my database. So for this, it's super easy. Here we will use inheritance. We will create a class. We will call it base entity, and all the classes I have right here, they will extend this base entity. Okay. And this base entity needs to be annotated with a special annotation, and this annotation is called MappedSuperClass. So this annotation indicates that a class is a superclass that is mapped to a database table. And this annotation is used to define common properties that will be shared by multiple entities without creating a separate table for the superclass. This means the only existence of this base entity is within our code, but from the database side, we will not see any table called base entity. So now let me show you how we can do this. Let's go back to our IntelliJ, and here within this models package, let's create this new class. Okay, so let's create a class, call it base entity, or base class, or base table, call it whatever you want. So this base entity, first thing that I need to do is I need to give it a MappedSuperClass entity. And as you can see, it's always from jakarta.persistence.MappedSuperClass. So this means, and this will indicate that this class is a mapped superclass, and any entity that will extend this one will inherit also all the fields that we have right here. Okay, and for this I will create a private local datetime. This one, for example, created at. I want to add a private. So this one, last modified at. And I want also to create two strings, for example. This is just an example, and you can create, or you can move all the common fields that you want into this base entity. So here I will create a string created by. So to track who created this entity, I mean like the user who created this entity, and we have also last updated by, or last modified by. Okay. All right. So here within this mapped user class, we can use all the Jakarta, all the persistence annotations like colon, last modified by, last created by, and so on and so forth. So it's a normal entity, but it's just within our Java code base. Okay. Now also let's check right here. For all the classes, or for all the entities that we created right here, we have this integer value, this integer ID, which represents the ID of our entity. So also, if you have always the same name for all the entities, what we can do also, we can also move this entity right here to this base entity, right? We can use this field right here. So now we can see that we have this ID, generated value, and so on and so forth. I will also just go ahead, add some Lombok annotations to generate the getters and setters, and so on and so forth. All right. So I will just copy this one, and I will give you a small hint, which is super important here when we work with Lombok. So here we see we have all the getters and setters, but here within this one, this is going to be the parent entity, and we want to use a builder. When we use a builder within a Derived class or the child class, we will not be able to access these fields right here. And to do so, Lombok, they created an annotation called superbuilder from the, for now, it's from the package lombok.experimental and might be moved later on, but the annotation is called superbuilder. All right, so here what we need to do first is use this superbuilder with all the entities that will extend this base entity, or in any case, if you have inheritance between your classes and you want to use this builder annotation, just go ahead and use this superbuilder instead. All right, so now let's go back to this author entity, and we see right here this one is in red because we don't have the primary key. But once we extend our base entity, this error will move on. Okay, so this is now gone. All right, and also when we use inheritance and we use this data annotation, we need also to add the equals and hash code annotation. All right, and here it needs to call the super. So these are some hints for you when you want to use correctly all the annotations from Lombok and also from the JPA or Java Persistence API. Also go ahead and check my course about Lombok and the useful annotations that you can use and also how they work. All right, let's move on right now. I will also make these changes to all the entities we have right here, and when we restart the application we want to make sure that we have everything as we had before. Plus, I want to see these 4 fields right here. Okay, so I will go ahead and do it for all of them. So what we need to do, or the way we need to implement this, so let's first replace this builder with super builder, and let's extend the base entity. Next, we need to remove this ID field with the annotations. And that's it. So this is how we can extend, or this is how we can inherit from this base entity and keep everything working fine. Also, don't forget to add the equals and hash code annotation. Let's do the same for lecture. And so this one extends base entity. Let's move this ID field. You can skip this one like for the rest of the entities if you are familiar with that. And here, and I will also do adding equals and hash code. All right, so next one is resource. Same thing here. Let's also extend our base entity right here and remove this ID field. Next one is section. And then we will restart the application and see the changes. So let me remove this and extend the base entity. All right, replacing also the builder with the super builder, and here we also need to add the equals and hash code, and then you can optimize the imports to have your code as clean as possible. All right, so here what we have, or this is what we have right now. Let's go first and check the database, make sure that we have everything as before restarting the application. Let's make sure that we have the same structure and the same tables that we have right here. Okay, so now go ahead, start the application, because I stopped the application. That's why we don't have any tables right now, because we have the property create drop. But let's start the application first. So everything is started and we have all the entities, but we don't see that we have a base entity getting created, and this is what we expect. Now I will refresh the schema right here, and we see that we have these 6 tables, all right? Author, and this is the join table. And if I open this author, I see now I have 9 columns, including this created at, created by, and last modified. Also, I still have the same ID, and this ID is inherited from this base entity. So this is how you can group the common the common fields within one entity, and this can make your code a bit cleaner, and you can group. And if you want, for example, to change the type from local date time to, for example, just java.sql .date here instead of this local date time, you can do this change only in one place instead of doing this change in all the places. Also, for example, if you want to link this created by and last modified by to the real user table in the database, you can just update and modify in one place. So this is how the MappedSuperClass works. And as I mentioned, finally, before we end this part, using the MappedSuperClass annotation can help you avoid duplication of code and make it easier to maintain common properties in large applications. However, keep in mind that the MappedSuperClass does not have its own table, so do not forget this one. And if you want to use a MappedSuperClass entity, so do not expect to have a separate or its own table. And it cannot be queried or persisted directly. So we cannot query this base entity, and we also cannot persist this base entity. It can only be used as a base class for entities. All right. So if you have any questions, don't forget to drop me a message. Otherwise, let's move on. Now let's talk about inheritance within this part of our class diagram. All right, so we have here, just a reminder, we have our resource, video, file, and text. Okay, so let's first prepare and create these three classes. Right here, I will create class called video, file, and text. And then let's explain and see how we can implement the different inheritance strategies. Okay, so let's go back to our IntelliJ, and here again with this models package, I will create three classes. But first, I want to go and open these resources, and I will just roll back all these changes. I mean, I want to use this integer right here. Why? Because we cannot extend multiple entities or multiple classes using Java. All right, so this is the only and unique reason for that. So because our focus right now is the inheritance regarding this resource. Otherwise, I can also show you how we can do, or how we can implement multiple inheritance. All right, okay, so this is what we have right here. And now I will just go ahead and create my first class. I will call it video, and this video, it will have also the same without the entity. I will just copy these annotations, the Lombok annotations, but here instead, as I mentioned before, it should be super builder. And for this video, I will have right here a private int length. So it's just the length of the video. I will create another class like we have right here. We have file and text. Okay. Now I will create a file class. So this file, it also will have the same annotations, and here I will use the super builder instead. Do not forget also to update or improve the imports. And here I will have just private string type. So the type is just to say if it's, for example, PDF, TXT, Word, and so on and so forth. All right, let's create now the third class, which is text. Also, do not forget to paste the Lombok annotation and change this one to a super builder. And within the text, we have our private content attribute. Private string content. And that's it. Now we have the three files or the three classes that we have: video, file, and text. And now we can go back and start explaining and implementing the different inheritance strategies using Spring Data JPA. let's first see the single table strategy. So this strategy is a way to map an inheritance hierarchy to entities to a single database table. This strategy is used in Hibernate or Spring Data JPA, or mainly when we talk about the Java Persistence API, so JPA, to define how inheritance is implemented in the database. With the single table strategy, all subclasses of the inheritance hierarchy are mapped to the same table. And then we need to talk about a discriminator colon is used, or we need to use it to distinguish between the different subclasses. So the discriminator colon contains a value that indicates which subclass a particular row in the table belongs to. And when the single table strategy is used, all of the properties of the parent entity class and its subclasses will be persisted to a single table. The discriminator colon is used to determine which subclass a particular row belongs to. Now, the single table strategy is the simplest way to implement inheritance in the database, but it can lead to inefficient queries and a large table size. It is best suited for situations where the number of subclasses is small and the inheritance hierarchy is not deep. So this is theoretically how single table inheritance works. Now let's try to implement this. First of all, to implement the single table strategy, so we go first of all to the parent class or the base entity, or whatever, you can call it whatever. And in our case, this is our base entity or the parent class. But first of all, here, this one needs to be super builder, because if in case you need it later on. And now here we need two things. We still have this entity annotation, which we need, and we need also to add this inheritance annotation, and it's the one from always jakarta.persistence. All right, and within this inheritance annotation, we can define the strategy. And here we can see that we have joined, single table, and table per class. All right. But as you can see right here, by default, it's using single table. So whether you precise single table or not, it will be by default single table. Okay. So you can just use inheritance annotation without the strategy. So it will take as a default value the single table. All right. So this is the first step. Now let's go to this video, file and text. And in here, optimize the import first. Let's call up this one. And now within this video, I will just add the entity annotation. Okay. So the same, and here from this video, we need to extend our resource, because a video is also a resource, right? And don't forget, with this data annotation from Lombok, when we use inheritance or we extend another class, we need also to implement the equals and hash code with the attribute or the property called super equals true. This is just a reminder for you. Let's go ahead and do the same for file. So here we need the entity annotation, and now we need also to extend our resource entity. And then we need to add the equals and hash code annotation. Let's do the same for text entity. Let's extend a resource right here. And finally, we add the equals and hash code annotation. All right. So here we have everything up and ready for us. Okay. Now let's restart the application and see what will happen with only this configuration that we wrote right here. So click on restart. So now the application is up and running, and we see that we have no exceptions. So everything is good so far. Let's move this one, and here let's go back to our database. Click here and update or refresh the database. So we have the inheritance within the resource column, and we see now that we have 9 columns within this class. Okay, so we see here that we have ID, name, and so on and so forth, but we see here that we have the extra field, and we see here that we have the size. This one, this is the one coming from the file or from the video. We have also the type, we have the content, and so forth. We have also the length. And what happened right here with this basic configuration, so Hibernate, he grouped all the fields within the parent entity. So everything now is within this resource. And if we want, for example, to create a content and so on and so forth, if we want to create a new instance of type text, we need to fill all the information, including all the information from the resource, including the content. Okay, now let's try to give some more differentiation between the entities. All right, so let's see what we can do as extra configuration to make this more clean and more beautiful to use. All right, so now let's talk about this discriminator value. This discriminator value will give a value that we will specify in advance to each type or to each derived class. So for example, if we give the value V for video, F for file, and T for text, we will add a column called type right here to the resources. And then this resource type, every time we create a new instance of video, this type will be automatically V, F for file, and T for text. All right, so let me show you how we can do that. So here we have our inheritance strategy, which is single table. Now we need to add another annotation, which is discriminator colon. And this one, it's just to give the discriminator colon name. And here for this name, by default, it's D type. If we do not precise this colon, by default, it will be D type like we have right here. Okay, so it's the discriminator type. But let's give it a special name. Let's call it resource type. All right. So from the parent class or the parent entity, we need to add this discriminator colon to specify the colon that we want to use. Otherwise, you can leave it to the default one, which is D type. All right. Now let's go to the different entities. Now, after this entity annotation, just go ahead and add a discriminator value. So this discriminator value, let's, for example, as we mentioned before, let's give it V for video. I would just copy this annotation and paste it in the different entities, F for file and T for text. So now if we restart the application, we will see that instead of this D type colon, we will have our resource type colon right here. So I will restart the application, and here the application is restarted. Let's open the database and refresh it again. So refresh this resource table or all the database. So within this resource, we see that we still have 9 column, and now our column is called resource type. All right, and we have this name, size, and so on and so forth. Those are the attributes that we have from all the children classes. All right. Now, if we create a new instance, or if we want to persist a new file, we will insert all the data, including, for example, for the file right here, we have the type. We will say, for example, PDF right here and all the information, and automatically this resource type will be V. So the value of this resource type, it will be automatically F, sorry, not V, because F is for file. So it will be F for file, and it will be V for video, and so forth. So you don't need to worry about worry about filling this resource type, because every time you create an instance of the children or the child class, it will be automatically filled using this discriminator value. All right, so this is how it works. And in the next step, I will show it to you in action. We will insert, for example, a new file or a new video into the database, and we will see what will happen. Let's see now in action how we can, how this is gonna look like. All right, so I will close everything right here. And in this repositories package, I will create a sample repository for this entity called video, because we want to check only one of them. So here I will create a new class. I will call it video repository. So for you, in case you want to use inheritance, you need to create, of course, one repository per entity. Okay, and here let's extend JPA repository, and let's give it the type video, and of course integer for the ID. So this is our repository right here. It's ready to use. Now let's open our main class, or our JPA application class, where we have the Spring application repository, and I will inject right here our video repository. I will call it video repository. Okay, and I will bring back this bin annotation. Okay, so this is gonna save this author, but I will just comment this out because I don't want to insert any other lines. So now let's use this video repository to insert one data. So I will have here var video equals video.builder.build. So for this video, I will just precise or give some information like the name, for example, ABC dot length. Let's check our video right here. We have the length, and let's say, for example, it's 6 minutes or 5 minutes. It's also okay. And let's give it another information, which is I guess that's it. Okay, so let's give it just the name and the length. And here let's use our video repository dot save this video entity. Okay, and now all we need to do is restart the application and see what will be inserted in the video or in the resource table into our database. Let's restart now. So the application is restarted, and we see also that we inserted something into the resource table. And here we see that we have this resource type, but we did not precise it. Just to remind you, here we have only the name and the length. Okay, let's check this resource table right here. I'm going to refresh the database or the table, and then double click it to show the content. So we see the content right here, that we have, first of all, we have V for the resource type, and this is something that we did not precise. We have the ID, name, we have the size, which is 0 because it's an int. That's why it's 0, because int by default equals 0. And we have the URL type, and so on and so forth. Also, we have the length that we precised. So we have the name ABC, and the length equals 5, and the resource type is V. So if we do the same for file and text, it will be F for file and T for text. So this is how single table strategy using discriminator colon and discriminator value. This is how it works. So if you have any question, just go ahead, drop me a message. Otherwise, let's move on and check the next strategy. Now let's comment, first of all, this bin annotation, close this class, and now we will talk about the next strategy, which is joined table. This strategy, each subclass in the inheritance hierarchy is mapped to a separate table with a foreign key pointing to the base table. This allows each subclass to have its own table with only the properties that are specified to that subclass. Okay, so when the joint strategy is used, each subclass will use or will have its own table with a foreign key pointing to the base table. This allows each subclass to have only the properties that are specific to that subclass, which can lead to more efficient queries. However, it also requires more tables and foreign keys, which can make the database schema more complex. The joint strategy is a good choice when you have a large number of subclasses with significant differences in their properties and you want to optimize the performance of your queries. However, it's not suitable for situations where you need to query the entire inheritance hierarchy at once, as it requires multiple joins to retrieve the data. So these are, let's say, the pros and cons of this strategy. Now let's see how we can implement this. So let's go back here to our resource. Let's collapse this one and let's go back to our resource entity. So now instead of this inheritance, first we need to comment out this one because we don't need this discriminator colon anymore. And now for the strategy, instead of single table, we will use the joined one. All right, so this is the only required change from the base entity. So we have this entity and again, the inheritance with the joined strategy and no discriminator colon is needed. So this one, I will just type it right here, only with single table. All right, so you don't mix when you directly check the code, you don't mix with this annotation right here. All right, so now let's go to the subclasses. Let's start with this video right here, for example. And now for this video, we don't need these discriminator values. So let's go ahead and remove them all, because now, as we mentioned, we will have a table per subclass. Okay, so that's it. This is how the join table works. Let's restart the application and check what will happen. So now the application is up and running. Let's open our database and refresh it. So refresh it right here. So we see now that we have this file, we have this text, and we have this video table. So let's check the columns. Here we have this content and the ID. Also, we have one foreign key, which is this ID, which is pointing to the resource. All right, so this text table contains only this content, which is the attribute that we specified right here. Let me make it in both sides. So we have only this content right here, and we have this ID, which represents the primary and the foreign key at the same time, because we see right here that we have these two icons, the blue one and the golden one. So they point to the same thing. So it's primary and a foreign key at the same time. And we will see the same thing if we open this video right here. So we have also the length and the ID. And now let's try to insert some data. We have already something in here within our JPA application. Let's bring this bean back. Let's restart the application and check what will happen. So now the application restarted, and we see here that we have two insertions. Instead, we just created a query, or we just inserted one element into our video table. All right, so here what we have this video.builder, and we precise the information of the video, but we see right here that we are inserting into resource and we are also inserting into video. So let me show you how this is represented as data in the database. So first of all, I will open the resource. Let me make this one full screen. So here we see that we have the ID, we have the name, which is ABC, the one that we specified, and we have this default values for the rest of them. If I open the video right here, I see that I have this ID colon, which is, as I mentioned, which is the primary and the foreign key at the same time, and we have the length that we specified. So automatically Hibernate inserted two elements or two lines into two different tables because we have our strategy as joined. Okay, now let me show you something you might also want to do in case, for example, you want to give a special or a custom name for this ID colon which represents the foreign key. We can use an annotation for that. All right, so let me make it full screen. I will keep the bean for now and I will just comment it out once we are finished with this join table strategy. All right, so within this entity, or within this entity called video, which is a subclass, here we can use an annotation called primary join colon. Okay, so this primary join colon, we can give it the attribute name, and here I will call it for example video ID. All right, so now when I insert or I restart the application and we will insert some data, we will see that this ID right here, this column right here, ID, it will now be renamed to video ID. Let's restart this. So first of all, we can see it already in the insertion query. So when we insert into video, we have length and video ID. Also, if you scroll a bit up and you check the code of creating the table video, we have length and we have video ID instead of ID. So by default, it will use the ID name or the ID name field of the parent class. So in this case, it will use this one. But if we want to customize it and have our own name for each entity, we can also use this primary key join colon. So let's open this video and we see right here, it's now called video ID. All right, so that's it. So this is how joined table works. Again, before we finish, let's go back to our JPA application and let's comment this out, and in case we need it, we will bring it back again. All right, so if you have any questions, don't hesitate to drop a message, write me an email, contact me on social media. Otherwise, let's move on. Now let's see the table per class strategy. So the table per class strategy, each concrete subclass in the inheritance hierarchy is mapped to a separate table. Abstract subclasses are not mapped to a table, and their properties are inherited by their concrete subclasses. So you may ask the question, what is the difference between this joined table or and also the you might ask the question, what is the difference between the strategy joined and the strategy table per class? So it's super easy. Let's check now. We still have the joined table right here. So here we have the resource that contains the columns of the base entity or the parent entity, which is name, size, URL, and so on and so forth. And each subclass contains only its own attributes with the ID in plus. All right, now when we talk about a table per class, this means that we will have a table with a table video, for example, with all the attributes from the resource table joined into this text table. All right, so this is the main difference. This means that we will create a table per each subclass. So when the table per subclass strategy is used, each concrete subclass will have its own table with a copy of all the properties inherited from the base class. This allows each subclass to have only the properties that are specific to that subclass, which can lead to the most efficient queries. However, it also requires the most tables and can make the database schema more complex. So in case you have multiple inheritance or many subclasses, so your schema might be a bit complex than the normal. So the table per class strategy is a good choice when you have a small number of subclasses with significant differences in their properties, and you want to optimize the performance of your queries. However, it's not suitable for situations where you need to query the entire inheritance hierarchy at once, as it requires multiple tables to retrieve the data. Now let's see this in action. Let's see how we can implement this table per class strategy. So the implementation is super easy. There is not a lot of things that we need to change. So first of all, let's go back to our base entity, and here instead of inheritance joined, let's use table per class. All right, so this is the first change, and I will just go back to the video right here and comment out this primary key join annotation because it works with the joined strategy. So that's it. All we need to do to mention here that we want to use a table per class. Now let's see the impact when we start the application, and then we will see, or let's also comment or bring back this bin annotation, and let's see what will happen when we insert a new video within our database. So let's see the schema changes and also the impact when we insert data. So first of all, we see here that we have only one insert, which is inserting into video, and we have the lecture, name, size, and so on and so forth. Now let's see how this is represented in the database. So now I will go back here and click on refresh. And we see right here that we have this, for example, this video table right here. We have our all the attributes, and we have the size and so on and so forth. So we have all the attributes from this resource table, and we also have the attributes from the video. All right, so if I open this video, we see right here that we have the ID, name, size, and so forth. So we have all the information joined into one table per subclass. And if we check also, for example, file or text, we will find the same thing. So here we have 6 columns, and this is the content or the attribute that we have from the text. All right, so now this is how inheritance works with Hibernate. Let's go ahead and check a few issues that we might face when using inheritance and how to solve them. When we work with inheritance, we can also query the base entity. So we can define the strategy that suits us, and we can also, or we want, for example, to retrieve all the resources of our database. Okay, it's like select star from resource and that's it, or like using the findAll method. All right, but we have one issue, is when we query this resource table, we want, for example, just to get all the informations or just the attributes of this resource entity, and we don't want to get any information about file, text, video, and so on and so forth. I just want the resources, not the subclasses of that. So this is this one, like in the background. So in the background, when querying the base class, which will return all the subclass records as well by using a union statement in the background. And the use of union can also lead to inferior performance when choosing this strategy. Another issue is that we can no longer use identity key generation. All right. So when we use this type of inheritance, we might face the issue of polymorphic queries. So as mentioned, querying a database class will retrieve all the subclasses entities as well. Now, if we don't want a subclass to be returned by the type of the query, we only need to add a Hibernate annotation to to say or like to exclude it from the definition. So for example, if I want to exclude this video right here, if I want to exclude this video entity when I want to query the resources, I need to add one annotation to exclude it from the parent when I query the parent. All right, so this annotation is called polymorphism. And here I need to give it a type. So polymorphism, and the type right here, it's polymorphism type dot explicit, because by default it's implicit, means when I query the resource.java, it will automatically query all the subclasses from that one. But if I say I want it to be explicit, this means that it will query this video only when it's required or only when I ask for it. Otherwise, it will not query it. Okay, so this is how we can solve the polymorphic queries issues. So just go ahead, use this annotation and exclude all the subclasses that you don't want to query. Okay, so if you have any questions, don't forget to drop me a message. Otherwise, let's move on. In this chapter, I want to teach you how to work with embedded IDs or embedded entities, generally speaking. All right. First of all, let's define what is an embedded IDs or embedded entities. Okay. So in software, we come across many use cases when we need to have a composite primary key to define an entry in a table. A composite primary keys are that use more than one column to identify a row in the table uniquely. So within one table, we can define more than one column to be the unique identifier of that column. Okay, so we represent a composite primary key in Spring Data JPA by using the embeddable annotation on the class level. This key is then embedded in the table corresponding entity class as the composite primary key using the embedded ID annotation. We will see all that in details. But first, let me give you a use case for that. So here, like I have this other table 1, other table 2. It's just an example to tell you that this is an independent database. So now let's take the case or the use case of a microservice. And now we will talk about the order microservice. All right. And here we have, for example, this order table. So this is just an illustration example. It's not a real life example, just for illustration. And here, let's go back and we take this order table we have right here. And we don't want to rely on generated IDs. Okay, I don't want to create a generated ID, which is auto incremented to be my unique ID of this table. But I want to have my own ID. I want to create my own ID. But this ID, I want it to be composed. Why I want it to be composed? It's not just a want, but it's a need. Why? Because in real life, one user can order or can pass or validate many orders at the same time or in one day, for example. Okay. So in this table right here, we can find the same username multiple times. So this means that we cannot rely only on the username. Okay. So we have here order date, and the order date itself, we cannot just rely on this order date because at the same time, even at the same milliseconds, we can find more than one user ordering something. All right. But when we talk about the composition, when we talk about username and order, both of them, this is unique. So both of this username, the combination of the username and the order date, it's unique. This means like the unique identifier of one order will be the username, for example, Alibu as a username, and the order date, let's say the 01/01/2023. at, for example, let's say midnight. Okay, so at this time, we have only one user, this Alibu user. He's the only one passing this entity, this order. Sorry, not the entity, but the order. But we can also find another combination at the same order time, but within another username. So like the combination of username and order date is something unique and we can rely on. So this is the use case, or one of the use cases when we need to use embedded IDs. All right, so now let me show you in action, let me show you in real life how we can create embedded IDs and how we can use them within our entities. In order to demonstrate that, let's first create and prepare the ground for that. So to use embedded entities and using the embedded IDs, what I will do, I will create a sub package within this models package, and there I will put all the entities and all the resources related to this embedded ID example. So right click right here on the models, and then I will create a new Java class. I will call it order ID. And this order ID, I will create it within the package embedded. Okay. So I will just call create a package called embedded, and within this package, I will create my class called order ID. Hit enter, and now we have our package, and also we have our entity. So now, in order to create an embedded ID, so first of all, you need to define the IDs or the attributes that you want to rely on to use that as an ID. And as our case demonstrates, so we want to have something composed of username and date, or we can call it order date. So I will first of all create a string username. And here I'm just assuming that the username is something unique. So we don't have two users with the same username. Then let's create a private local date time. Let's call it order date. So this is the username, or this is the entity. Well, actually it's an entity, but it's not a persistent entity. It's something like the MappedSuperClass, the example we saw before, but it's not a persistent entity. It's just a composition where we can compose multiple attributes and we can use them as an embedded ID. So first of all, we need some annotations. I will use the data from Lombok, all args constructor, the no args constructor, and here I will use one annotation which will make this one an embedded entity. So here the annotation is called embeddable, and this embeddable comes from jakarta.persistence because we are using Spring 3. This is just a reminder, so let's use this embeddable annotation. Using this embeddable annotation, we'll tell Hibernate and Spring Data, generally speaking, that this is an embedded entity. Now, how to use it, I will show you just right away. So within this embedded package, I will create my order class or order entity. Okay, so I will call it order. And here I will just copy this information. So these are the annotations that I will need. And of course, my class is an entity, so we need the entity annotation. And first of all, I will create a string. Let's call it order info, for example, and a private string, another field, because our focus is not about the fields, but it's just to say that we have few information or few fields within the order entity. So now we see the same error that we know here when we create or we map a class or a Java class with the entity annotation. So it will claim about an ID. So here it says that this persistent entity order should have a primary key. And here it's asking to add an attribute or an ID attribute. For us, as we mentioned before, we don't want to use an auto-generated or an auto-increment ID, but instead we want to use this order ID class we just created. So first of all, I will create an instance of that, or a field of type order ID, and I will call it ID. All right. So for now we have this order ID, but it's still not known as an ID for this entity. Now to make this one an ID, we use the annotation embedded ID. All right. So this embedded ID right here. So here we see we also still miss something, but first I will go back to this in a few seconds. First I want to show you, and I want to go quickly to the documentation of this embedded ID annotation. So here it says applied to a persistent field or property of an entity class or MappedSuperClass. So here you need to focus, it's entity class or a MappedSuperClass to denote a composite primary key that is an embeddable class. The embeddable class must be annotated as embeddable. So this is the annotation we already used. Also, there must be only one embedded ID annotation and no ID annotation when the embedded and ID annotation is used. So this means when we want to use the embedded ID annotation, we cannot have another ID annotation within this one. All right. So next, it says that the attribute override annotation may be used to override the column mappings and so on and so forth. And this one we can also skip. You can have the time to read it. And here it says if the entity has a derived primary key, the attribute override annotation may only be used to override those attributes of the embedded ID that do not correspond to the relationship in the parent entity. Okay. And here also you can see an example. We have, for example, this employee primary key with this embedded ID. And here we see that we have this dependent ID annotated with the embeddable annotation right here. Okay. So this is a bit and quickly the annotation of this embedded ID. Now let's go back and check this error right here. Okay. So here it says that the class order ID should implement the serializable. So when you want to use an embedded ID, absolutely think about extending and implementing the serializable interface. Okay, so this order ID should implement serializable. So the serializable is the one from java.io package. Now, if I go back to the order, now the error is gone and I have my entity. So within this embedded package, I will create my order class or order entity. Okay. So I will call it order. And here I will just copy this information. So these are the annotations that I will need. And of course, my class is an entity, so we need the entity annotation. And first of all, I will create a string. Let's call it order info, for example, and a private string, another field, because our focus is not about the fields, but it's just to say that we have few information or few fields within the order entity. So now we see the same error that we know here when we create or we map a class or a Java class with the entity annotation. So it will claim about an ID. So here it says that this persistent entity order should have a primary key. And here it's asking to add an attribute or an ID attribute. For us, as we mentioned before, We don't want to use an auto-generated or an auto-increment ID, but instead we want to use this order ID class we just created. So first of all, I will create an instance of that, or a field of type order ID, and I will call it ID. All right. So for now we have this order ID, but it's still not known as an ID for this entity. Now to make this one an ID, we use the annotation embedded ID. All right. So this embedded ID right here. So here we see we also still miss something, but first I will go back to this in a few seconds. First, I want to show you, and I want to go quickly to the documentation of this embedded ID annotation. So here it says applied to a persistent field or property of an entity class or MappedSuperClass. So here you need to focus its entity class or a MappedSuperClass to denote a composite primary key that is an embeddable class. The embeddable class must be annotated as embeddable. So this is the annotation we already used. Also, there must be only one embedded ID annotation and no ID annotation when the embedded ID annotation is used. So this means when we want to use the embedded ID annotation, we cannot have another ID annotation within this one. All right. So next, it says that the attribute override annotation may be used to override the column mappings and so on and so forth. And this one we can also skip. You can have the time to read it. And here it says if the entity has a derived primary key, the attribute override annotation may only be used to override those attributes of the embedded ID that do not correspond to the relationship in the parent entity. Okay. And here also you can see an example. We have, for example, this employee primary key with this embedded ID. And here we see that we have this dependent ID annotated with the embeddable annotation right here. Okay. So this is a bit and quickly the annotation of this embedded ID. Now let's go back and check this error right here. Okay. So here it says that the class order ID should implement the serializable. So when you want to use an embedded ID, absolutely think about extending and implementing the serializable interface. Okay, so this order ID should implement serializable. So the serializable is the one from java.io package. Now, if I go back to the order, now the error is gone and I have my entity. Okay, so if I start my application, I should see my order class or my order entity created in the database, and I should see a composite primary key. Okay, so let's go ahead, click start and check these updates. So let's check the logs. Okay, here we see an exception. So the exception is we have a PSQL exception, and this is because we have a syntax error near order because the order is already a reserved keyword. So to solve this, you already know the solution. Let's use the table annotation. Okay, let's give it a name and let's give it underscore order. Right? So now restart the application and we should see everything working fine right now. All right, so the application now is running. We check, we don't have any exceptions, no issues. And also we can check the logs and you will see that we have our order table getting created. Okay, so now let's go ahead, check our database, refresh and see. So here we have this order table. Let's open it and we have already 4 columns. So for these 4 columns, we see that we have this order date and username. Both of them, they contain or they have this golden key icon. So this golden key icon is the primary, or is the icon of the primary key. So our primary key in this database is the order date and the username, both of them concatenated. All right, so if we check the keys right here, so we see that we have this underscore order underscore p key, so it's order primary key, and it's a composed key, and it's composed already of this order date and username. So this is how we can create an embedded ID. In case you need to create an embedded ID, now you have the knowledge to do it. So if you have any questions, don't hesitate to drop me a message. Otherwise, let's move on. So now we saw one example or one usage of this embeddable annotation. I want to show you another one. Let's go back to our diagram right here. And for this order, for example, we want to have, or we want to add some information about the delivery address, but we want this information to be embedded within the same entity or the same table right here. So I don't want to store the address or the delivery addresses in a different table, but I want it to be within the same table order right here. You might say this is so easy to do. All I need to do is within this order entity right here, I just declare the information of the address, okay? But yeah, the answer is yes. But imagine we want to use the same address object also to store the address information with our tables within the same database or within the same schema. So like this, what I need to do is to duplicate the code in each entity, which is not good. Okay, we have a better solution. Okay, the second one, you might say I can use the MappedSuperClass and extract all these entities and just extend my entity with this address entity. I say, okay, this is also feasible, but if you have multiple inheritance right here, if you already, for example, extend a base entity, or if you extend another, or you have inheritance within your database. So what should be the solution? The solution can be using the embeddable entities. All right. So within this package embedded right here, right click and create a new Java class, and let's call it address. Okay. So this address, first of all, we will need the same Lombok or the same basic Lombok annotations right here: data all args constructor and no args constructor. And now I will just create few dummy fields. So here I will have string street name, private, also another string house number, for example. House number, it's a string just in case you have 1A, 1B, 1C. And private string zip code. So it's also string, it might start with 0, and so on and so forth. So let's not focus so much on the fields right here, but our main focus is to understand how this embeddable works. So once we create and once we define all the attributes of our embedded entity, as we did in here within this order, we need to use this embeddable annotation. Okay, so let's use this annotation right here, and like this we just created our embeddable entity. Now I will show you how you can use this embeddable entity as an attribute within another entity. Now let's go back to our order class, and within the other fields that we created, I want to create a new field of type address. So I will create an address and I will call it address. All right, so now I want to tell that this address is an embeddable entity within my order entity. All right, so I already mentioned the solution. So let's use the embedded annotation. Okay, so here we have embedded ID and this is embedded, and let's check quickly what is this embedded annotation. So it specifies a persistent field or property of an entity whose value is an instance of an embeddable class. So the embeddable class must be annotated as embeddable. All right, so the attribute overrides, and so forth may be used to override mappings declared and default or defaulted by the embeddable class. So here you can also override some attributes when you use this embeddable class. All right, so this is the embedded annotation. Now let's go ahead, start and test it. Click on restart right here. So our application is up and running right now, and let's go ahead and check the database. So now I will just refresh the database and let's see what will happen right here. So within this order table, we see right now that we have 7 columns, and here we see that we have the house number, street name, zip code, and so on and so forth. So the fields of the address are now included or embedded within our order table. So if you want to do, or if you have a need and usage like that, or use case like this one, always think about using embeddable entities. All right, so embeddable entities will make your code much easier and improve the granularity of your code, and your code will be really reusable. All right, so because this address entity or this address class right here, we might use it in many places. So in order to duplicate, not in order, but instead of duplicating the code of the fields of this address class, just create an embeddable entity and use it or call it whatever you need. If you have any questions, go ahead, drop me a message. Otherwise, let's move on. Previously, we explained the hierarchy of the Spring Data JPA interfaces and how this helps us and provide us with methods and predefined methods to search data and query data from the database. So now we cannot talk about Spring Data JPA and not talk about querying data from the database. And querying the data means reading and writing and also deleting and all the interactions and the transactions that we can make with our database. The Spring Data JPA and the repositories and the JPA repositories, they provide us several ways to dynamically generate queries at runtime. So these are called query generation from method names, or also known as derived query methods. Okay, and these derived query methods, they allow you to define queries based on the method name and of the query method you are calling. So for example, if you want to find the author right here, let's first, before going to this method right here, let's just recap and remind about what we have. So we created before an interface called author repository because we have an entity called author right here. And this author repository interface extends already the JPA repository, which is a generic interface that takes 2 parameters. The first one is the entity in question, and the second one, the ID type that we use within this entity. Okay, so this JPA repository will use the author.java, our entity that we created. And just a reminder, with the author, we have these IDs, or these, sorry, not IDs, but these fields. We have an ID, first name, last name, email, and age. Okay, so here within this author repository interface, which extends already the JPA repository, as I mentioned before, we can create methods. Okay, so it's an interface, and you know, within an interface, all we need to do is the return type, whether it's a function or a void, and then the method name and the parameters. This is how we create methods within an interface. So as I mentioned, Spring Data JPA provides us a way to dynamically generate queries, okay? And we called it derived queries or derived methods. So this is how we can write it. So here, as I mentioned, it's the return type and then the method that we want to, okay? So let's explain this example right here. We have this list of author. So our method will return a list of authors. And here we have findBy last name. And we have our last name, or LN, as you can call it as you want, as a parameter. So what will happen in here? So this findBy last name method generates a query that search the users or search the author with a specific last name. And this method right here, for example, this findBy first name and last name will generate a query that searches the authors or the user by first name and last name, okay? We can generate other queries like in here, for example, we can count. We don't have only the findBy, we can also count. We can also delete. We can also do as many operations as we know in SQL using the derived query methods. Okay, so for example, if I want to count all the authors in my database by age, so all I need to do is to write the return type, and Spring Data JPA will take care of the conversion. Okay, so the count all by age, within the age, it will create a query that counts all the authors in this author table by the age and return this value. Also, if, for example, we have already the delete methods that we can use, or the predefined delete methods, but if we want, for example, to delete the list, or we want to delete a list of authors by age, all we need to do is delete all by, and then we have age, like by, and here it's followed by the property that we want to use. Okay, so let's explain a bit more. Here, in order to generate one of the methods right here that will create a query behind the scenes at the runtime, all we need to do is we have findBy and then followed by the property. Okay, so this is the simplest way. So it's findBy and then followed by the property name, and depends on the return type right here. Spring Data JPA will determine what to return exactly. So here we have findBy, so it will search everything from the database and return the result set. Okay, but if we have, for example, here an author or an optional of authors, so I will explain the difference. So an optional is the design pattern null pointer. So this is a wrapper to wrap this author object within this optional class right here. So this find by email, Spring Data JPA will search the author by email from the database and then return a type of an optional of type author. Okay, so also the same here, we have this find by email, but in this case we will return the author. So Spring Data JPA will do nothing except creating an object author and just return it. Okay, so here, as I mentioned, we have the findBy followed by the property, and then you can create as many methods as you want. Okay, so this is the first one. Also, we can use FindAllBy. So they both work in the same way. We can use FindAllBy last name, FindAllBy first name, and so on and so forth. Okay, now we can also combine properties. Combine means what? We can use operators such as and or. So I can search the list of authors by first name and last name. Okay, so here we see that we have findBy first name and last name, and we need to pass these two parameters. Okay, so fn for first name, ln for last name. Okay, we can also use, for example, let's go back to this method. I want to ignore the case when I want to query all the authors or the list of authors from my database. So here we can say find by last name and then followed by ignore case. Okay, we can also use other operators like not, like we can use find by last name like, so means this contains, and so on and so forth. Okay, so we will see all this in action. We will see how we implement, or how we can implement these methods. Okay, so I hope this part is clear. If you have any questions, don't hesitate to drop me a message. Otherwise, let's move on. Now let's see all this in action. So first of all, I will teach you how you can write these methods. So as we explained before, first of all, we start with the return type. So here, imagine we want to fetch the list of authors from our database and from this author table by first name, for example. Okay, so when we say that I want the list, automatically think about having a list. Okay, so here you can whether work with lists, array lists, collections, and so on and so forth, but I always recommend using interfaces. Don't use classes, use interfaces. So in order when you want to change the implementation, it's easier. Okay, so let's go back. So here we have a list and then the type. So we want a list of author, and then you have this findBy. So automatically when you type findBy and you have the type as list, so it will automatically transform it or map it to a list of authors. You can also, when you work with lists, you can also use FindAllBy. FindAll means that you want to search everything. Okay, so they both work in the same way. So let's use FindAll. So then here, if you have the IntelliJ, the ultimate version, or for the people who are using another IDE which provides auto completion, so here when you do command space or control space, you will see that your IDE will propose the list of properties or the attributes that you have within the author. Okay, so and here you can have a look on the generated or the auto-generated properties, which are automatically detected from this author entity. Okay, so we can see age, for example, and even within the age, we can see that we have a lot of methods. Okay, so imagine we have all these methods within only the age property. For example, if I want to search all the authors where the age is null, so I only need to query FindAllBy age null, age not null, age not like, not in, and so forth. So you can have a look on all these methods, and we will explain most of them. Okay, so here, for example, I want to search all the authors by first name. So all I need to do is to type first name. Okay, and within this first name also, I can see that I have a lot of auto completion. So after, before, between, by the way, not all of them are applicable, because when we say first name, after, here mainly we are talking about dates. Okay, before also dates, and between, and so on and so forth. So you need to be careful. Not everything auto generated here is usable or applicable for this specific property. Okay, but you will learn it by the time. So now this FindAll by first name is completely sufficient. Now I need to provide my parameters. So here you have the same type like in here, and then just type any name. I will call it fname just to mention and to make sure that this works. I don't need to pass the same here, the same attribute name. Also, one thing worth mentioning, and it's really important. So you see this first name right here. If I go to my author entity, you see that we have the first name is written in exactly the same way. So we have first and the name with the capital N. Okay, so if you go back here, you cannot say like this. You cannot call your method like this. So it will not be detected. It will not be highlighted as an error. But within your IntelliJ or within your IDE, it might be highlighted as a warning, but not for other cases. But this worth mentioning. So here, the only thing that you need to change is the first letter, because you are using camel case. So what you need to do is just copy the field that you want to use, and until you get used to it, copy it, and then here just paste it, and then you change only the first letter to a capital letter. Okay, so like this, you will have the method or the exact method that will work for you. And if I change this one to, for example, a lowercase, we see that it's highlighted, and here we see that cannot resolve property first name. This means that my IntelliJ or my IDE, he automatically detected that this first name property is not within this author entity. Okay, so here you need to always be careful about this. All right, so this is our first method, and this one will search all the lists of authors from our database by first name. Now let's try and see how we can improve or how we can extend this method. Okay. All right, so let's try how we can extend and improve a bit this query. Just as a reminder, I want to remind you that this query is the equivalent of this one. Select star from author where first name, I will use it as in the database. Let's say this is a native query, equals, and here we have our first name as parameter right here. So this is the same exact query. Now let's answer the following question. What if I want to find all the authors from my author table where first name equals any, for example, equals this, and I have in my database the users are all in capital letters, okay, are all uppercase, but I want to ignore the case. I want even to pass, when I pass this Ali as value, I want always to query the data. So within this method right here and this generated query right here, passing this value Ali and having all the first names in the database equals or in uppercase, this will not work. This will return an empty list. Okay, this will return nothing. Now let's try to extend this query and make it ignore the case. All right, so here we have find all by first name, and I already gave you the answer. We need to add one property which called ignore case. Okay, so when we say ignore case, now it will accept this query right here. Okay, and it will return some data. All right, so this is good. Now, what if I want to get all the data or all the authors from the database where the first name contains this one, for example, contains AL, all right? So, and also I want it to be also ignore case. In order to do so, I will duplicate also this method. So here we have find all by first name, ignore case. We can also add containing. So we need find all by first name, containing, and then ignore case. So as you can see here, we can concatenate and we can use multiple filters within the same query method. Okay, so here we have find all by first name. So this is the attribute name, and then the condition that we want to use, or the where clause that we want to use, containing. So containing will be the equivalent of this one right here. So it will be something like that. Okay, so it's gonna be like %%. So this is the exact same thing. And also we want to insist that we want to ignore the case. So here, be careful, it's property, condition, or where clause, and then the refinement if we want to refine our query. Okay. So now I want to, so this one, I hope it's clear. Otherwise you can drop me a message and I can explain it a bit more. Now I want to get all the authors where the first name starts with this, and also ignoring the case. All right, so in order to do that, let me just keep this as it is, and I will duplicate this method. So I will use it always as a base method. I will copy or paste this query right here. So I want, as I mentioned, to search all the authors from the database where the first name starts with this. So here, instead of containing, I will use starts with. So here, when we use this starts with, the query will be transformed or will be generated exactly like this. Okay. And also here we want to ignore the case. Now let's take another case. Let's play around with these queries because it's really funny. So here, instead of starting with, I want all the first name that ends with. Okay, that ends with, sorry, I just made a mistake. So starts with, it's like that. So it's AL and then anything, because this % means anything, but ends with is the opposite one. Okay, so I'm sorry for that. So here I need all the queries or all the authors from the database where the name ends with AL. So it starts with anything and ends with AL. All right. So here I will duplicate the same method. And here, instead of starts with, I already gave you the answer. So I need to use ends with. And you can see that this ends with ignore case will transform and will create this exact same query in the background. Okay, so we can also add and play with so many attributes, and as I mentioned, like after the first name or after the property name within your IDE, you can click on Control Space and you will see so many methods. Okay, so starting with, ending with. Also, you can check if the author or if an author exists with this first name. You can also use in and so on and so forth. Okay, so for example, if you want to generate this query, so I want the list of authors from the database where the first name in, for example, I want to filter only for example, Ali. I want to get all the authors where the name is whether Ali or Boo or coding. So here it's super easy. As we mentioned before, let me duplicate this method. And here, instead of ends with, I need to pass in. Okay, so, and also here ignore case. So I want to find all the names or all the first names from the author table where the first name is in a list. But here we need to pass a list of strings. Okay, so to pass a list of strings, so whether we pass a table or we pass a collection. Okay, so here we need to pass a list of string as the first names. I will call it first names, and this will generate behind the scenes this exact same query. All right, so you can play with these methods, with these filters, and you can generate awesome queries out of this. Now let's move on and try something else. Now, before moving ahead and going deep into these derived query methods, let's play a bit with what we created right here. So to do so, we will go to this Java application here where we have our command line runner bean, and we need to insert some data into our author table. So in order to be able to play with these queries. But here we face a small issue, which is that if we want to insert multiple data, I need to every time to create, for example, if I want to insert 50 authors into my database, I need to duplicate this code 50 times, and each time I need to change the first name, last name, age, and so forth. But to do so, we can use a dependency which help us to fake data. Okay, so this dependency is called faker, or called Java faker. So it will automatically generate data for us, including, for example, first name, last name, emails, and so forth. Also, it can generate address, and so forth. All right, so first of all, let's go ahead and insert and add this dependency. So open the pom.xml file and go down to the dependencies right here, and after the project Lombok, add the following dependency. Okay, so add the dependency tag, and within the artifact RD, it's called Java Faker. So it's the second one, not the fixture, but it's the second one, Java Faker. So select this, and then it's from com.github.javafaker. Right, and the most recent version at this time is the 102. If you have more or a recent version, just go ahead and choose it. Then click on this load Maven changes, and that's it. You will have the Java Faker within your project. Okay, now let's insert some data. First of all, don't forget to bring back this bin annotation. Let me make this full screen. And then we need to comment out this one. And to comment this out, all you need to do is select it and then go to code. And here you have this comment with block comment. Okay, now let's bring back this code right here. And what we will do, let's create a loop. So I will do for int I equals 0, I smaller than or less than. Let's insert 50, and here we have I++, and let's move this code inside. Now, instead of this first name and last name, I will remove the email, or let's keep it like that. The age, we can also keep it. But here, instead of this first name, last name, what we will do, here I will create a faker. I will call it faker equals a new faker. Okay, so this is how we can use our faker object. And now for the first name, I will use faker.name. We see here that we have this name object which returns a name. And from this name, we have first name, name, last name, full name, and so forth. So we need the first name last here. And also let's use the same one for the last name right here. So instead of first name, let's use last name. Okay. Now for the age, we can use our faker dot number, and here we can generate a number or a random number between 2 digits, for example. And the age, I want my author to be between, for example, 19 and maximum, let's say 50. Okay, so it will, like this, it will generate an age or a number between 19 and 50. Okay. All right, so now we can just run our application and make sure that we have all our authors inserted into the database. So let's go ahead and do it. Okay, so here we forgot that our email should be unique. So to do that, I will just do something like this, just to fix it quickly. And here I will concatenate it with I. Okay, so it will be contact 0, 1, and so forth. So like this, we don't have the applications. I will restart the application and see. So now we see that we have the insertion logs. Let's go ahead, refresh our database and check. Let me move this, refresh the data. And here we have our tables. And now let's go and check our author table. Okay, so we see right here that we have this email, and we see that we have this first name, last name, and so on and so forth, and the information that we provided, also the age. But now let's make this insertion permanent. And because here, as you remember, when we start the application and we made this DDL auto right here, like just to remind you the configuration, the DDL auto we created is create drop. So all we need to do is to make this one to update. Okay. So when we make it update every time we will start the application, we will not lose the data. So this is what we need to do. So in order to do that, just go ahead, make this property to update like this, and then what we need to do is to restart the application so we can insert the data. So just follow me on this. Restart your application, and then we will have the data inserted. So here we have in our database, let's refresh it. We have this data right here, and this data will be persisted like always. Okay. And then we go back here. In order to make this data always persistent, just go back right here and you can just comment out this insertion, or you can also keep it. But here we want to play with this part right here. But let's comment out all this for loop. So let's use a block comment. So we no longer have this code getting executed. And to make sure that what you did is correct, just go ahead, restart again the application, and make sure that you still have the data. So here we should not see any SQL log telling that we are inserting, and as you can see, the application is already started and nothing happened. So also if I refresh my database, if you open the table right here, click this refresh button, you see that we still have the data. Okay, also let's just to double check, let's refresh this, open, and we see that we have the data right here. Okay, so now we have permanent data within our database, and now we can play with it. Now I want to give you a small exercise. So here we prepared everything, we have all the ground we need to run our tests. So now I want you to play within this repository, this author repository, and the methods that we already generated right here. So within this command line runner, or if you want, you can create a service and some endpoints, and you can play with these methods. But just go ahead and test this FindAllBy methods and see the output. Okay, so I hope you like this exercise. If you face an issue, drop me a message. Otherwise, let's move on. Well done. After you played with all these methods that we created together, now let's move on and check something else. So here we have our author table already inserted with data, and we can see here that we have email, first name, last name, and age. And for this one, I just want to highlight one thing, because here for this email, what I used here, I used the faker.name.username, because I'm sure that this username will give me a unique username. And then I made a concatenation with the @alibucoding.com. So you can also do the same. Also for the age, you can use the faker.number and then number between, and it will give you a random number between 20 and 80, for example. All right, let's go back here. Now we have the data inserted. Now, what if I want to update, for example, the first one, which has the ID equals 1. I want to change the email, first name, last name, and age. Okay, so in order to do that, it's so easy. Here we will keep this one, and also I will keep the bean, because in the application here I have create drop. So this means every time I start the application, I will get my data inserted. Okay, so after inserting the data, what I want to do is I want to create, or I want to copy paste this one, or I can copy the whole code. And here I want to update author with ID 1. All right, so in this case, what I will be doing is I will create an author object, and here I will just change the data, and here I will make it first name Ali, last name Bu Ali, and the age, it will be my age, for example, and the email, I will move it back as it was. So contact@alibucoding.com. And then, of course, I will need, okay, I forgot repository.save here. And then I need the same thing here. So now this one, it will insert this, this author. But if I do .id here 1, so this means that we will update this author. And let me explain how this works. So this save method, first of all, it will check the ID. So if we have an ID, the first thing that it will do, it will try to fetch any object within this ID. So it will make select all or select star from author where ID equals 1. If the Hibernate can find data, what it will be doing, it will be merging or updating all these fields. Okay. Otherwise, if, for example, I pass an ID equals 1 million or 100,000, so it will not find any object within this ID in this author table. So it will decide that it will be an insertion or creation of a new input. Here, you need to really pay attention that when you pass an ID, the ID should exist in the table. You should already know the ID in order to update something. So now let's move on and rerun the application. So we will have all this information, but the element or the first one should be Ali Bu Ali, and with the email contact@alibu.com. All right, so here we see also that we have all this insert, and then you see here that we have a select and then an update. So the first select is checking if we have the author with the ID that you specified in here, which is the ID 1. And then we have update author, set age, and so on and so forth. And then where ID equals the ID that we passed as parameter. So now I will just refresh this one, and you will see that if I search for the ID number 1, which will be at the end, we see here that we have the urge34, alibucoding.com, Ali, and Bu Ali as a last name. So this is a way of updating the data. Now, what if I want, for example, just to update this one, or only I want to update age or all the ages of my table? So for example, what if I made a mistake and I want to fix all the updates, or I want to update all the ages of all the authors in the author table? So in this case, I need to write one query which will update everything. So I don't have a condition right here, like I don't have an ID. And if I want to use this method, I need first of all to find all the authors from the table, and then I have to loop over them, and each time I need to set the age, and of course I need to pass the ID and then repository.save. But there is an easier way, and we will see it just right now. So what I want to do now is running the following query. So I want to create a method or create a mechanism that will allow me to run the following query, which is update author, and then set, or let's call it set a.age equals 22, for example. And here, let's start first of all with where a.id equals 1, for example. So I want to have, or I want to execute this query. So it's exactly the same thing like here, but I want to use the JPA or the my repository right here. So here I have the author repository, and I will show you how you can use this repository in order to run or to create update queries. So first of all, go to this author repository, and I can just copy this one. And then what I will do, I will create a void, or let's create an int method. So update author, just update author, it's okay. So in order to update the author, we need to pass an int age and then int ID, because we want to update the age of the author having the ID 1, for example. And here, as we mentioned, we want to run this following query. So in order to do that, so we will use the query annotation, and then this is our query. So it's update author a set a.age equals 22 where ID, and now the ID should be like this. All right, so this ID will refer this one, and the age should be also age. So this query does not support update methods or update instructions, but we need now to tell Spring Data JPA that this is an update query. And in order to do that, all we need to do is to add this modifying annotation. So when we have this modifying with this query right here, Hibernate will understand that this is an update query. So now if we go back here and if I comment this out, and then if I do repository dot update author, and I pass, for example, 22 as age, and I pass 1 as an ID, and rerun the application, we will see that in the author table we will find that we have an update. Okay, here we see that the application did not run, and we have already one exception. So we see that first of all we started to insert everything, and then we got an exception, failed to execute command line runner, and then executing an update or delete through an exception. So let me explain to you what is the reason behind that. So the reason is that this update method that we have right here was not or is not transactional. So in order to do that, or in order to fix that, we need to make this modifying query transactional, because the modification or the update need to be within this same transaction. Okay, so in order to fix that, all you need to do, so here you need to put in mind that when you use the query and modifying, then you need also the transactional annotation. So with these three annotations right here, modifying, transactional, and query with the update query, we will be able to update our author. So now let's run again, and let's also check the output. So we see here that we have all the inserts that we have, but now we have no select as we saw before, but it's directly updating. So update author set age where ID equals something. So let's go back to our, and now if I scroll down and I see this one, so we see that the ID number 1 has the age 22. And also if you want to make sure, you can just put one age equals 100, for example, since we know that all our authors ages are between 20 and 80. So now we can make sure that we updated the correct one, and also the update method or the update query is working as expected. So now we see that the age of this guy right here is 100. So our update query is working. Now if you want to, or now let's try to update all the ages, or the ages of all the authors that we have. So first of all, I will create void update all authors, for example, ages, and here I will just pass an int age. And I will also copy this one, and all I need to do is removing this where clause. And now I will duplicate this one, update all authors, and I will set the age to 99, for example. This one we can comment it out, and I will rerun the application. Oh, we missed something already. So here we need to use the update all authors and the age 99, and I will remove the ID. So let's start again. Okay, so we see here that update author set age equals to something. And if I refresh right here, I should see all the ages equals to 99. So this modifying query and this modifying annotation right here is really useful if you want to do a bulk update and you want to update many things at the same time. So you don't need to loop over the data and set this, set that, set this, set that. So all you need to do is to create an update query, and then if you need, and also don't forget, if you need these workflows, you need to add it. Otherwise, you will be updating all your data. In this part, we will see together the named queries. So in Spring Data JPA, named queries are useful in a variety of scenarios for organizing, optimizing, and maintaining query definitions in your application. And some common use cases includes encapsulation, for example, of your query logic. So named query help you separate query definition for the rest of the application logic. Also, named query are reusable. They also help us optimize the performance of our application because the named query are validated and parsed and often optimized during application startup. So when you have a named query, it will be parsed, validated, and optimized on the application startup. Also, named queries are centralized. This means named queries allow you to store your query definition in one place, either with an entity class or an external XML file. This externalization simplifies query management and makes it easier to update and refactor the queries. Let me give you some specific examples when to use named queries in a Spring Data JPA application. So first of all, when you have complex queries that are used in multiple places throughout your application, when you want to optimize performance for frequently executed queries, when you want also to improve code readability and maintainability by separating query definitions from other application logic. And finally, when you need standard way of organizing and managing queries across your application. So these are the use cases, or some of the use cases of named queries, and the definition also of a named query, but you need to keep something important in mind. While named queries offer several benefits, it's important to note that they may not always be the best choice for every situation. For example, they might not be as flexible as dynamic queries. For example, when we use Query DSL or Criteria API. Also, when it comes to building queries based on varying condition or user inputs. It's essential to evaluate your specific use case and choose the appropriate approach for your application. All right, now let's move on and implement our named query, and let me show you how to do that. To create a named query, first of all, you need to go to the entity or to the model where you want to create that query. So here we have two options. First of all, we can use this annotation named query, or we can also use named queries. So we have two options, okay? Also, we have another one, which is named native query or named native queries right here. So you can also create native queries as named queries. So for this case, let's move on and let's go ahead and create JPQL named queries. So first of all, we will use a single one, and I will show you how you can use this named query, and then I will show you the use case or the usage of these named queries. So first of all, as I mentioned, when using named query, we need to give it a name, and the name, always think about having the entity name or your model name dot the name of the named query. So I will just say findBy named query, and then I will provide the query itself. So let's say, for example, for this one, I want to do select A from author A. This is just the alias, where A.age is greater than or equal, for example, to the age I want to pass as a parameter. So now I have a named query, which will fetch all the authors by age, where the age is greater or equal than a specific parameter. So now, in order to execute or to use this named query, just go to your repository right here, and now we want to execute this query, so it will be return a list of authors, and then we have findBy. And as you can see, IntelliJ is already proposing this one, And also you see that the icon is slightly different from the native one or from the predefined ones. So here we have findBy named query, and also as you saw here we have it's a named query. So all we need to do is to pass our parameter using the param annotation and then age, and then of course it's of type int, so it's going to be int age. So that's it. And here you see already the difference that we have this icon, and when you click on it, it will navigate us to the named query. Okay, so now in order to use this one or to check it, all you need to do is to go here to the JPA application, and then after executing and updating and doing all that, what I will do a list of authors equals repository.findBy named query. And here, let's say, for example, I want to fetch all the users having, or all the authors having an age greater or equal than this. Yep, so this one should be, or should go inside. And here it will be findBy named query. And then I can do, for example, for each system.out.println. So I just want to print all the authors that will be here. I guess we can also remove this one. And now let's execute our application and let's see the output. So here we see that we have all the authors, and here we just forgot to remove this update, because by this we updated all the authors and we set all the ages to 99, so it will retrieve all of them. So now let's see, and here we have a restricted list, and as we can see here we have all the users where the age is 74, 71, and so on and so forth. So for example, if I change this one to 70 or 77, something like that, yeah, okay, and if we run again, we will see that we will get a shorter list. So you see that we have only two with the age 71 and 70. All right, so this is how we can create a named query. Let's move on and let me show you how we can create a list of named queries and how we can create another type of named queries. Now let's update data using named query. So let's try to recreate the same query right here, but using the named query. So first of all, I will just copy this one, and then I will go back to the author, and I will create another named query right here, and then I will give it a name. So the name will be author.update by named query, and the query will be the one I just copied. So here it will be update author set age where ID equals something, but here I will just remove this ID, and I want to update all the authors. So again, I need to go back here. So it will be a void update by named query. And this one, of course, we need a parameter, which is the age, and then int age. All right, so let's double check. So here we have a variable age, so we need to pass it, and this is what we did right here. Now let's go back after displaying all this data. Now update with named query. So all I need to do is my repository dot update with name or by named query, and here I will pass, for example, 12 as an age, and I will execute the application again and check what will happen. So it seems that it did not work, and now I guess, and I'm pretty sure that you know why it did not work, and the answer is, so let me first show you the exception, failed to execute command runner, and here it says expecting a select query, but we got an update. So the answer is that is the one you already thinking about. We need this modifying, and of course we need the transactional annotation. So even if it's a named query, if it's an update query, we need always to use this modifying. So let's run again and check. And now we see that we have this update, and then if I open my table right here, and I will see that all the ages now are 12. So that's it. Also, before we move on to the next steps, Here you see, or we mentioned already, that we can use named query or this annotation named queries. The difference between this named query and named queries, actually there is no difference, because if we go to the source code of this annotation, we see that we have, or we can pass a list of named queries. So it's just a way to organize our named queries. So we can do something like that, and we can move these named queries inside. And that's it. So this is the only difference between the named queries and the named queries. So you can whether have them separately, or you can also group them within a list of named queries, and nothing will change. It will be always the same. Everything will remain the same. All we need to do is just group them with named queries. Spring Data JPA specification is a powerful and flexible feature provided by Spring Data JPA framework that allows developers to create dynamic and type-safe queries using the JPA Criteria API. It enables you to build complex queries based on various criteria, which can be combined and reused in different scenarios, providing flexibility and maintainability in constructing queries. And the core of the specification, the core concept of Spring Data specification revolves around the specification interface, which is a functional interface with a single method. So here we see in the source code that we have a bunch of static and default methods, but the main method, or the main important method, is this one, predicate to predicate. Here the T represents the entity type on which the query is built, and the pred2predicate method receives 3 arguments. First of all, we have the root right here, which is the object that represents the root entity in the query, from which you can navigate to other related entities and attributes. And then we have a query, which is a criteria query of a type interrogation mark, which can be any type, which is an object that represents the overall query being built. These can be used to modify the query structure and or add additional constraints. Finally, we have the criteria builder, which is of type criteria builder, which is an object that acts as a factory for creating various query elements like predicates, extensions, and orderings. The toPredicate method returns a predicate, which is a Boolean expression representing the query condition. Now let's talk about how we can use this specification. So to use the Spring Data specification, you need first of all to extend your repository with this JPA specification executor interface, which provides methods to perform queries using specifications. The most common used methods are findAll and findOne. You can also create custom specifications instances by implementing the specification interface or by using lambda expression. So specifications can be combined using the AND and the OR method. As we can see right here, we have this AND and we have this OR. Also we have where and not. These methods allow us to build complex queries dynamically. In summary and overall, Spring Data JPA specification is a feature that leverages the JPA Criteria API to build dynamic and type-safe queries for your application. It provides a flexible and maintainable approach to construct queries based on various criteria, which can be combined and reused throughout your application. This approach is particularly used when dealing with complex queries that depend on user input or vary based on runtime conditions. Now let's move on to the action and let's implement our first specification query. The first step in implementing specifications is, first of all, you need to go to your repository where you have or where you extend your JPA, the JPA repository. Also, we need to extend the JPA specification executor. So here we extend already JPA repository. I will also extend JPA specification executor, and here we need to give it the same type author in here. All right, so now we have our repository ready to be used as a specification executor. After extending the author repository, we need to create a new class. So I will create a new package here. I will call it specification. And then I will create a new class, call it author specification. And now within my author specification, I will create two specifications, or let's call them two predicates. And these predicates, they will filter, for example, my authors based on the first name and age. So let's create the first one, public static specification, and my specification is of type author, of course, don't forget that. And let's call this one has age, for example, and this is gonna be our first filter. So first of all, it's gonna be int age, and then we need to return a lambda expression. So you know, when the two predicate method that we checked before, it takes root of type author, let's call it root, and then we have the criteria query, and this one, as we mentioned before, it's going to be an interrogation mark. This is our query, and we have our criteria builder. Now let me just inline these variables so you can see everything. So here we have these are the parameters that we need, as we explained before. So we have our root of type author, we have the criteria query, and the criteria builder. So here what I want to do, or like what we need to filter out, is first of all, if this age right here, so for example, this is just a check, if it's less than 0, so I will just return null, because we know that we don't have any age or any person having a negative age. Otherwise, I will return my criteria builder dot equal, and then I need to pass the expression. So it's the root that holds the information of the entity dot get, and then I can pass the attribute name that I want to filter on, which is age, and then the age itself. So here I'm ensuring that this method has age right here will add a criteria, or will add specification that the age of the author right here, this variable or this field right here, should be equal the age that we will pass as a parameter. So just I need to remind you that what we are building right here is not the query itself, but it's just, or are just the filters that we want to use. So for example, I want to filter all the authors by age and the name containing or starts with. Okay, so next one, I will build a public static. Again, it's a specification of author, and then let's say first name contains or starts with, and here I need to pass my first name, and I will just copy paste this one. So here, if my first name is null, so I need to return null. Otherwise, here I want to do first name, and here of course I need the parameter. So as you know, in SQL, contains is not we don't have such method called contains, but we have a method called like. So like, I want to have this first name to be like the parameter that I want to pass. So now we just built two specifications, or two predicates. The first one is has age, and it will check that this author has an age that we will pass as a parameter. And again, we have this first name contains, or let's maybe call it first name like to be more consistent with this method right here. And this will check that the first name that we will pass as a parameter contains or is like the first name that we have in the database. So now let's move on, and let me show you how to use this specification class that we just created. Now let me show you how to execute a specification. But first of all, let's prepare a few things. I will go to the application YAML, and here instead of create drop, I will make it just update, because I want to have some persistent data and I want to check what we have in the database. So this is the first one. and then I will just keep this one for the first time. I will execute the application, and I will then just remove all this one. So I don't want to update the ages. I don't want to find anything. All I need is just to execute it for one time and make sure that I have some data gets persisted. So here we see that we have all the inserts, and if I check again my table, we have the data inserted, and then all I will do is comment this out, and now I can stop the application and we can now implement or run our specification. So in order to run the specification that we created, first of all, we need to create an object of type specification having a type author, and let's call it spec or specification. It's as you like. I will use spec as a short name, equals specification, and then dot where. So this is our where clause. So the first filter of our where clause is this one, this author specification that we created. So first of all, I want to filter by age and first name. Okay, so I want to get all the authors having the age equals something and first name equals something. So here I can use author specification dot has age, for example, let's say 34, let's just imagine. And so here we can use or we can even pass another predicate, but we can rely on and or. So let's say and. Also, again, I want to use my author specification and then first name like. So for the first name, I will again refresh this list and take, for example, this one. Okay, so I want to fetch all the authors having the name, for example, starting with or containing this Mitch. Okay, I will say MI, just MI. Okay, so then once we are done with creating or declaring our specification, I will do my repository dot find all, and then within the find all method, I can now pass my specification as a parameter because our repository already extends or implements the JPA specification executor. So here I will just do for each and then system.out.println just to print out our result. So let's click and run the application and see what will happen. So we see here, first of all, we have an exception. And the first thing that we see in here that could not resolve attribute first name. And let me show you why. So this first name here, we said that I want to have the first name like, but let's check our author. So the author, it's first name with a capital N. So this is important to have exactly the same thing. All right. So now I will run again and check. So here we see that we have the select, but we don't have any result. And you may wonder why. I can tell you. So when we use the keyword like, when in the SQL, when we use this keyword like, we should always use like, and then it should be like this. So it should be %%, and then our filter right here. Okay. So this is what we are missing with the first name. So we need to do something like this. And then I will add % in the beginning and % at the end. So we need to surround this first name, the variable that we want to pass, with a %%. Okay. So whether we do it here or you can do it when you pass this parameter like this, but it's better to put it in the specification because like means that we have something like this. Okay. Now let's run again. And we still can't see our data. Let's first check the author. So we have our Mitch right here, and let's go back. Yeah, but Mitch, yes, that was the problem, but Mitch is 22 years old and we don't have any other Mitch within the same age. So now I will just change this one to 22 and run again the application. So here we see that we have at least one result, which is this guy called Mitchell, and so on and so forth, and having the age 22. So now, for example, I want to first to search only for I want to search only for the authors that the age is 22. So I just can comment this out and run my application again, or execute my query again, and this one, it will filter all the users that they are 22 years old. Or also I can do something else. So here, instead of and, I can say or. So find all the authors that are 22 years old, or the name is like or contains MI. So let's run again and check the specification return type. So here we see also that we have these two elements. So this guy is 22, and we have the first one is Mitch, and then we have this Paulita. So for example, also if I let's just play a little bit with the variables that we pass, and here I want to filter all the authors that the first name contains the letter I, and as you can see here, it's an I, it's an I, it's an I, and so on and so forth. So this is how you can create dynamic queries. And also the best part of specifications is you can reuse all these methods that we created. All these predicates or all these specifications are reusable, and you can reuse them to create dynamic queries. Okay. So for example, if you have a search or a complicated or a complex search query, you can use specification in order to prepare and in order to create your query in advance.